My name is Lee Liming. I work at the University of Chicago with the Globus team. My colleague here, Steve Turoscy, is also in the Globus team at University of Chicago. Both Steve and I are members of the sub-team within Globus called Professional Services. And what we do, what we're responsible for, is helping people to integrate Globus with their applications. And so we do that both in sponsored research projects where we're being paid by a funding agency to do it. And sometimes we do it in unpaid forum too. So, when we get support tickets or we get, just email inquiries, people asking us, how would I do this with Globus? I want to add this Globus feature to my web application. We are the team that gets engaged to do that. So the topic for today is how to jumpstart your data-intensive science gateway with the Django Globus portal. So before I get started, I wanted to just make one comment about the scope of this tutorial. This is, Globus does a lot. There are a lot of different APIs that you can use in Globus, and integrating it with a portal can be complicated. Particularly if you are doing things from scratch. In other words, you're starting out with our API documentation, learning how to use it without anything else that's been provided, and adding it at the API level. It's a lot to get started with. And so what we have realized over the last few years is that it's easier to give people an example to start with. And so that's what the Django Globus portal is. The Django Globus portal is a full-fledged portal, data portal that is developed in the Django framework, which is a Python web application framework, very template-driven, and has a lot of integration with other Python frameworks. So it's nice to use. A number of people use Django for their portals. So it's a good thing to use as an example. And it's already been integrated with the features of Globus that we're going to be talking about today. The reason that that's helpful is because it gives you something that you can start with right off the bat, without having to learn an awful lot about all the low-level details of Globus. So the important thing to take away from that is that if you have already a web portal or a web application and you just want to add one or two Globus features to it, this would not probably be the way to go about doing it. This would be a way to see, okay, I see how they did it. Now I can replicate that in my portal. And that would be helpful, I hope. But we are, for this tutorial, going to be using a full-fledged portal that already exists. It's open source. It's available through GitHub. We're going to show you how to get it. And in fact, if you want to, you can actually do that during the tutorial. So to that point, let me put this screen up. Copy down that URL. It's very short, bit.ly/gw-tut, T-U-T. That URL put into your browser will bring up a much longer URL, well, not too much longer, but a little bit, that has a bunch of reference materials and cheat sheets for this tutorial. So go ahead and copy that URL down, maybe even open it up in your browser now. Let me show you what it will look like, just so you know you're in the right place. It should look like this. It should say Globus World 2022. That's where we put all this together, and we're reusing it today. Tutorial materials, it tells you about some test endpoints. The most important thing, if you want to do the hands-on exercises, is to click this first link here where it says claim your virtual machine here. If you click that link, it will take you to a Google Sheet that should be publicly available for everybody, and you can write in it. If you put in your name and email address here, This check mark for blank lines will change to an X, which means you've claimed one of our tutorial instances. And then off to the right, you'll see a host name, or I'm sorry, it says server IP address. It really should say host name. And that is the name of the tutorial instance or tutorial virtual machine that we've created that you could use during this tutorial. And it's already set up for you. It has it has the accounts that are listed here, admin one. It'll whatever number of the, whatever row of the spreadsheet will fill in here. So it'll be admin 3, admin 4, admin 5, whatever. Those are the user IDs that you'll use to log into it when you use an SSH client. So you'll need to SSH in. And the password is, hang on one second. Probably should write this for you. I'm just going to put it over here. Password is Globus. Uh-oh. Yeah, okay. So I knew it a couple minutes ago, but I forgot it already. Let me get it. I can get it. We were discussing this earlier. Do you have it handy, Steve, by any chance?
Is this the password for, yes, I do. Hold on. Yep, I have it. Let me.
I knew I should have had this handy.
Lee, I'm going to post it. There's an issue with the spreadsheet. It is
yeah,
not,
you could put it. You could
well,
put
it's
it,
not. I'll put it in there. But the spreadsheet is not public. So people are having issues claiming a VM.
Sorry. Okay. Anyone with the link can edit. Done. Okay. Anyone with the link should now be able to edit. Sorry about that. We usually lock it down when we're not doing a tutorial, and I forgot to unlock it this morning. You might have to reload. Oh, nope, Mono's in. Okay. Yeah.
There we go.
Okay. And Steve, could you put that password in the Zoom chat, please?
Oh, yes. It should be in there. Can I pin it? Let me see. All right, the password is in chat.
Yep. Okay. Password's in the Zoom chat. Yes, I see it there. Okay, great. Okay, so what that'll do is that'll get you into an Amazon EC2 instance that we've set up for you you'll be able to deploy your Django Globus portal and get it up and running. In the first part of this tutorial, the first half before we go to break, we will go through all the introductory stuff, tell you a little bit about why we're doing this and what we're going to do. I'll demonstrate the portal for you live, and then Steve will show you how to bring up your own instance of the portal. It takes about 5 minutes. And that will show you how you can get a Globus portal up and running real quick. Now, of course, if you set it up in 5 minutes, it's not going to have your data in it. It's going to have our data. And so the second half of the tutorial after the break will be us showing you how to reconfigure the portal from using our data to using your data. So that you'll be able to, people will be able to search and browse data that you bring into the portal, and then transfer that data out of the portal for their own use in research. So that's basically the very high level agenda for today. Is the first part is going to be introduction and motivation, talking a little bit about the modern research data portal design pattern, which is what Django Globus portal is based on. Introducing Django Globus portal and deploying Django Globus portal, and then we'll break. And then after the break, we'll go to using your own data, reconfiguring the portal to use your own search index and your own Globus collection. And then hopefully we'll have some time when we're done with that to talk about remote computing using FunkX. which is a newer technology that's coming out of the Globus Labs team and our collaborators at NCSA at UIUC to do remote computation in web portals. So basically, the first half is going to be all conceptual and introducing the portal and getting it up and running in your own instance, should you choose to. If not, you can just watch along and see how it's done, and then go to the GitHub repo and do it when you have time later on. And the second half will be all about customizing the portal to use your data. Okay. Are there any questions before I launch into concepts and motivation? All right, let's forge ahead. So it's been, I think, 20 years now that I've been working with the Globus team. And across all those years, the story has pretty much stayed the same. Researchers are generating more and more data through their research activities. A lot of it has to do with bigger and better and more detailed and more powerful scientific instruments. Those instruments could be anything from a sequencer in a lab at a university. It seems like every university I go to these days has a sequencer somewhere on campus that someone got a grant to install. Those things generate about 1 terabyte of data for a sequence run. That's a big sized hard drive full of data. And you need to then analyze it and potentially share it with collaborators elsewhere. Maybe archive it for later use for reproducibility, et cetera. It could also be a cryo-EM microscope that does cryo-EM microscopy. It could be a satellite sensing system, satellite in orbit around the Earth that's generating imagery or generating data that gets transmitted to a ground station and archived somewhere. And you need to analyze that data. Or it could be something that's a kind of a one-of-a-kind, in the world, instrument like Argonne's Advanced Photon Source, a very brilliant X-ray microscope that can generate imagery of things down to the molecular level. Regardless of what type of instrument it is or what type of data source it is. Oh, and I suppose I should also mention there's another category, which is data that's produced by simulations. So if you have mathematical simulations of scientific phenomena and you run those simulations and it generates a lot of output data, that's another source of data. So it all comes down to doing things that generate lots of data and then having to do stuff with that. Whether the stuff is something as simple as sharing it with your colleagues so that they can do things with it, or if it's more complicated things like running your analysis codes over it and seeing how you change parameters in your analyses to get better results. Yeah, that's the story. So some of the things that we've seen happen over those years, the data rates generated by instruments and simulations are increasing dramatically. There's a lot of heterogeneity in the data. What I mean by that is that data generated by different people's instruments, different cryo-EM microscopes, different fMRI systems, even different simulations come out in different formats. And you need to normalize the data before it can actually be compared with data from somebody else's system. Also, there is a continuum of computing resources from being able to analyze things on your laptop, maybe with MATLAB or R or a tool like that, up to your campus systems, maybe I should say department systems, and then campus-wide systems, and then national scale systems. So researchers are using not only their own computers, but also computers that are shared with them, and need to be able to get the data that they've generated from their instruments or their simulations there so that it can be worked with and then possibly moved somewhere else so that it can be archived or stored for later use, maybe in a version 2 of the experiment or in reproducibility activities. And then another thing that is that we've definitely noticed is that when you're using, when a researcher has to use instruments provided by another team, it takes a lot of work to figure out how that instrument does things. Where does the data get put? How do I access it? What account do I use? What format is it in? What data transfer tools can I use to get the data off of the instrument, et cetera. And so there's a lot of detail in these research instruments and research systems that generate data. And it's an awful lot for any researcher to have to know, particularly if you end up using multiples of these. You know, if you use, you know, 2 different supercomputing systems, or if you use, you know, 3 different cryo-EM microscopes at different people's campuses, they're all set up differently. It's just an awful lot of figuring out the workflow. So here's a common flow pattern. You have some kind of instrument. I think this might be a cryo-EM system. And you use it to generate images or output data. And then you have a system, a computer system that is the data acquisition system for that instrument. So it's basically tied at the hip to the instrument. That's where the data actually lands from the imager or sequencer or simulation or whatever it is in the data acquisition system. Once it's in the data acquisition system, there's usually not a whole lot of storage available there. And so the first order of business is to get it off of there, out of the lab and into some system that's bigger where you can keep the data around for a while. So you need to move it to your advanced computing facility, wherever that might be. Now here it's shown as a big, huge, as a machine room that just goes on and on and on into infinity, it looks like. And maybe you're lucky and you're at a campus that has such a thing. Or maybe it's sitting in a closet in your department. Or maybe it's actually, you know, in a bedroom in your house. I don't know. But anyway, it's something bigger than what was in the lab. There's storage there, and hopefully there's some compute. So you do some work on the data that you produced. You produce some analysis results. And the next step would be to take the analysis results and create metadata that describes it, so that it can be understood by other people. How did you analyze the data? What do all the columns mean if it's tabular data? You know, how is it formatted? And you know, what are the units of measurement, and you know, anything else that has to go into understanding the analysis results so that it can be used or looked at and used by other people, and maybe even run through other analysis software later on. And that could be done on the same computing facility that the analysis was done on, or it could be moved to a different system so that it can be shared with other people. Maybe you're putting it in the cloud at that point, and other people will be pulling it from the cloud, or maybe you're putting it on a campus data, maybe a Globus endpoint at your campus, and people will be getting it from there. In any case, you have not just the data and not just the raw data and the analysis results, but also the metadata that describes what it all is and how to interpret all of it. And then finally, for most of us, the next step where things really start to get interesting is creating some kind of web interface that allows people to do things with the analysis results. It may be searching and discovering analysis results from multiple experiments or multiple samples that were run through the system. It could be different versions of the analysis run on the same input raw data. Regardless, you want a way for people who don't need to know how that original imaging system worked or the data acquisition system worked, or even the advanced computing facility where the analysis was run. They don't need to know the details of how all that stuff was done. They just need to look at what the results were and possibly obtain the results through downloading it or transferring it to their own system so that they can try their own analysis on it and see if they can do better or worse, or if it's just different, how is it different, and see if they can learn something interesting about that data. And so the last step, of course, would be hopefully science happens, because we have shared our data and we've shared our analysis and we've tried things different ways and we found out what works and what doesn't work, or what works differently. I'm going to take a moment to check chat, because I see that we have some chats here. Looks like we're on track. Okay. Oops, should have closed that. Okay. All right. There we go. All right. So, that was a pretty complicated case. There's a simpler one, really. It may be that all you really want to do is you have some web application that you've already set up, and what you need to be able to do is to enable researchers to import big data into your app. So you can do something with it. Maybe you have an analysis routine that you want to run over data from multiple people's labs. Or maybe people are in some kind of collaborative project where they need to share data that's gathered from multiple places. So if the challenge really is just that you want to let people import data into your web app, and the data is too big for normal web uploads, like let's say that it's terabytes of data at a time, or tens of terabytes of data, or bigger. We definitely have people who are working with data sets that reach the petabyte scale. Then, or if it's many files, maybe it's not that big. Maybe it's only about, I don't know, 10 gigabytes or 100 gigabytes, but it's divided up into 1,000 or 10,000 or 100,000 different files. That's more than most web upload tools will allow you to handle. And very often there will be some kind of accident or mistake along the way that'll stop a normal web upload from happening. And you would have to start all over again because it doesn't have a good way to restart. So another thing that people use Globus for in web portals is to provide just a way to import big data sets. And then after those data sets get imported, perhaps you also need to curate the data sets. In other words, you have a submission system where people are allowed to upload a big amount of data. And then before it can be seen and used by other researchers, you need to add the metadata, you need to catalog it, you need to quality control it. Maybe there is some kind of pre-processing that needs to be done on every submission that is uploaded to this system before it is shared with other people. Something that normalizes the data so that it puts it in a common format, maybe puts common metadata on it, or maybe even does some transformation of the data to put it into a common form before it gets shared with everybody. That is also something that you might create a web portal for, that you would want to have Globus features in. All right, so let's just summarize. The reason that we provide these portals and science gateways to enable a broader audience of researchers to access the latest data, also to access the latest analysis tools, So it's not just about collecting data, but it also might be about collecting algorithms and making them available to people so that they can use them easily without having to figure out how to install it on their own systems and get it running. It's also so in order to simplify access to complicated data sources. So if the facility that you are using to generate data is really complicated, there's no reason for every researcher to have to know how, all the ins and outs of how the guts of that system generate data and move the data on, up to the systems where it can be analyzed. We can simplify things by essentially introducing the researcher to the data in a web portal rather than having them have to SSH in somewhere and look in some directory and figure out where the header files are stored and all that kind of stuff. A nice web interface can simplify that significantly. We also might do it so that we can add curation and cataloging to make the data easier to discover or make the data findable. So in addition to delivering the data and have it be accessible, we also add metadata, add cataloging, possibly add quality control, and maybe pre-processing so that the data is findable in a format that people are expecting it to be in, some normalized form, so that they don't have to worry about where it came from and all the details of how it got there. We'll handle that for them and just let them go to the web portal to get the normalized data. One more reason that is not, we don't want to overlook is that a web portal also allows researchers to customize their experience. So very often a web portal will allow researchers to have preferences, favorites, for example. Here are things that I normally will want to be looking for. So, these are the search terms that I want you to add to whatever I type in. Also add these search terms. I only want to see data that's in a certain format or data that came from a certain place or whatever. You can in a web portal, researchers can customize their experience that way, and it increases their productivity. And then finally, one final reason that I wanted to put out there for why you might want to do things in a web portal is because the portal can help you to enforce access policies that may be fairly complicated. Researchers who are in a particular group are permitted to access data, these data sets, but other people can't. In some cases, there are things like data embargoes where data is going to be public. Everything that comes out of a project that will eventually become publicly available, but not for the first 6 months or the first year. During that time, the data is under what's called an embargo, which means that you have to be in the quota, the privileged people are able to access the data first, get some value out of it, and then it becomes public to the rest of the world. That's a very common policy in the research community. It also could be that there are in particular, when we're dealing with data that originates from human beings, from medical data or biomedical data sources, very often there are legal frameworks involved regarding privacy and health privacy. And sometimes the approval process for getting access, it is definitely the case that there are lots of people who want their research data to be available to researchers so that they can help cure diseases, for example. But they don't want it to be available to just anybody. They want it to be available only to researchers who are bona fide experts in their fields and actually have a chance of potentially coming up with a cure, and not just anybody in their garage who thinks that they might have a bright idea for how to solve cancer or some other disease. And so the approval processes might be complicated. There may be a data access committee who reviews proposals, researcher proposals to access data of a particular type. And the decisions of that data access committee have to be recorded somewhere and have to be remembered, and then used in granting access to the data. And so a web portal can make that easier. It can be a place where the policies that go into data access can be managed easily by committees or by teams. You can use groups, you can use other mechanisms. The one that I'm familiar with that's used by NIH is something called a passport. That basically records the decisions of various data access committees and says, okay, Lee Liming, has been granted access to these studies, and those are the only ones that he has access to. And if should he apply to and be approved for more, they'll show up in his passport later. But the web portal can make it easier to manage those kinds of access policies. All right. So now that we've talked about why we have portals, I want to really quickly go over what Globus does for portals, particularly. So one thing that Globus provides is federated logins. That's the ability to reuse identities that you've already created, maybe for your campus login systems, or for national systems like Exceed or Compute Canada, or the Department of Energy's laboratory systems, rather than having to create a new account just to use a new web application. So if you want that capability, Globus provides it very easily. You don't have to create a login interface. Globus can do that for the application and just tell the application, oh, this is Lee Liming from the University of Chicago. Go ahead and create a profile for Lee Liming from the University of Chicago and let him set up preferences and permissions and things like that. Globus also provides a group API that can be used for permissions. So if you want to set permissions based on group membership, you can do that. I think something that most people are familiar with is that Globus provides data upload and download at scale. So it makes it much easier to upload and download big data sets. And that can be uploading and downloading to and from your web application, as well as other things. Globus also provides a search API that provides index searches. We'll see that a lot over the next couple hours. That allows for these nice search interfaces like up here on the screen, with facets. You can click, just kind of like going to Amazon.com, say, well, I only want the ones that came from this particular experiment run, and I only want the ones from this year, and I only want ones that have this particular protein in it, and ooh, there are my results, cool. That's what the search API provides in Globus. So you don't have to code that in your portal yourself. You can have Globus do it for you. And then the last thing that Globus provides is automation. And so we have a number of different ways. At the end of this tutorial, I'll cover several different ways that you can do automation in your web application. Okay, real quick now. Everything that I just described that Globus does, you can do either in our web application, that is the Globus web app that we provide at app.globus.org, or if you just go to www.globus.org and click login, you get to our web app, and that's basically our web application that lets you move things around in Globus. We also provide a command line interface that allows you to script things. So if you like to write shell scripts or any kind of scripting, you can do that using our Python CLI. And pretty much anything you can do in the web app, you can do in the CLI. Or, and this is what this tutorial is really about, you can use our Python software development kit, or you can use our REST APIs using just RESTful API code and write your own applications. And so the only thing I want to say about that is that we're in this tutorial, we are basically doing the latter. We're using the Python SDK, but we've already done it for you in the Django Globus portal. And so you'll be starting out with an application that's already been written and learning how to customize it and turn it into the application that you really want. Let's see. So I just did something very similar to this, and I'm not sure if I want to repeat it or not. I think I will very quickly just give you an overview. There are 5 main APIs that Globus provides: auth, groups, transfer, search, and flows. What they do is what's on the screen. So auth is the federated logins, authentication and identities. Groups is about managing groups and group permissions. Transfer is about moving data around, and also something called guest collections that I'll talk about in just a sec. The search API is obviously for metadata and indexing, and flows is for automation. In addition to those 5 APIs, there's also a new thing coming out of Globus Labs. That's our kind of technology development group called FuncX, Function as a Service with Globus Identity and Access Management. So if you think of function as a service, normally you would think of Amazon Lambda functions, for example. And that's basically what FuncX is. In fact, it's built on Amazon Lambda functions, but we've added Globus's identity and access management on top of that. So it uses permissions based on the federated identities from Globus Auth and groups and group memberships from Globus Groups. So that you can give permission to your functions based on Globus identities and groups. And so I just wanted to make sure that you knew what the building blocks are that we're building on. I'm going to breeze through this. So Globus Auth, the idea there basically is rather than building your own username and password database and protecting passwords in that database and potentially, managing the security vulnerabilities associated with having a password database, you can instead reuse accounts that people already have provided by their campuses, research labs, other organizations. So the benefit to your researchers is that they don't have to create a new account just to use your app. They can use one they already have. The benefit to you is that you're not now responsible for protecting passwords and handling things like password resets and I forgot my password and all of that. You can let Globus do all that for you, and your app just gets information about who's using it. So when it's time for somebody to log into your app, you redirect them to Globus, and when Globus comes back, it says, okay, let me introduce you to Lee Lyman from the University of Chicago. That's the person who's using your app right now. And you can create a session for Lee, and you can create a profile for him and let him set his preferences and all of that. And you never had to worry about Lee's password or multi-factor authentication or anything like that. Let's see. The other thing that you need to think about using Globus Auth for is obtaining service or API tokens. So all of the Globus APIs are authenticated using tokens, using OAuth. That's the standard mechanism that much of the World Wide Web is based on. And in order to use the Globus APIs, you need an access token. And Globus Auth is where you get those tokens from. When somebody logs in, you the application say, okay, for this person logging in, I'm going to need a transfer token, I'm going to need a groups token, and I'm going to need I don't know, I'm going to need to be able to a token that'll allow me to access my guest collection for my portal, so that he can load preview images and things like that off of the data in my portal. And when the login flow completes, Globus Auth will not only tell you this is Lee Liming from the University of Chicago, but it'll also include the API tokens that you asked for, so that now you can use those APIs, and when you do, it'll have all of Lee Liming's permissions. And that allows your portal then to do things for Lee with the Globus ecosystem. Globus groups, really simply, you can create groups, you can set policies for who can join groups. Can people invite themselves to groups? If so, do you have to approve their memberships or not? Do they get auto-approved? Let's see, can people see who's in the group, etc.? So you can set all those policy things about the group. You can add and remove people from groups, and then you can check to see who is a member of what groups, or what groups is the person who logged into my portal belong to, or does the person who logged into my portal belong to this particular group? And you can use that for permissions in your portal. Globus Search allows you to create a hosted search index. So basically, you do not have to have storage for your search index. Globus hosts that for you. Basically, it is a search index as a service. The first thing you would do for an application is create a search index that you'll use in the application. And then you would start adding metadata to that search index, entries. And every entry is something that you know about a file or a data collection, or whatever you want to use as the subject of your search index. And then you can call API calls to do searches across the search index. Globus indexes all the entries, so that you can very quickly get, say, give me everything that, I don't know, has the keyword red in this particular field, or give me everything that, was from 1992. You will get back a nice JSON document with all of your search results in it. Yeah, that's probably all I want to say about search at the moment. Oh, except for one important thing. In addition to this ability to put metadata into your search index, you can also put permissions on the entries and say, this particular entry can only be seen by people who are members of group, I don't know, my portal group. And what that does then is it allows you to have different views of the data based on people's group memberships. So think about this in terms of curation. You could have a group that is people who are in my curators group. They can see anything that's in the curation pipeline. So, that hasn't necessarily been made available publicly yet. And people who are not in that group would only see the data that has already completed the curation process. All that can be done in search, in the search index. You can say, this entry is only visible to the curators. It's not visible to the public yet. And then later on, as a step in the curation process, you can change that permission and make the entry be publicly visible. So you can do, with permissions in your search index, you can change the visibility of the things that are stored in the index. And that allows you to do curation. It allows you to do quality control, and a number of other interesting use cases like that. Okay, let me go through there. Yes. Okay. All right. Okay, let's now talk a little bit about the modern research data portal design pattern. This is basically a a logical framework or a design pattern for building portals. This is the way we've been building portals in the Globus team for the research teams that we're working with. There is a paper for it, which is, well, there's a screenshot of the title of the paper on the screen here, and the URL for it on our docs site is available, docs.globus.org/MRDP for Modern Research Data Portal. So again, this is not code. This is a pattern, a design pattern that basically is, this is, you know, an approach to building portals. And the Django Globus portal that we'll be using in this tutorial is code that it's based on the MRDP design pattern. So the key elements of the Modern Research Data Portal are, first of all, a science DMZ. This is something that would be, that your institution would provide, that basically is a place on your campus networks where you can put data storage or data transfer nodes such that data can be moved into or out of your institution quickly and without having to go through the firewall that dramatically slows down transfer rates. So basically you set up what's called a science DMZ. It's only usable by services that are permitted. So for example, Globus would be one such service that is permitted to use the science DMZ. And because we trust Globus's security, we are okay with putting the transfer nodes in the DMZ, which is outside of the institutional firewall. So basically, the Science DMZ is a way of providing a fast data path to and from your institution and the storage systems that you have at your institution. So that's one part of the design pattern. It's not code, it's really networking and where you connect to your storage systems in your institution. The second hardware part is data transfer nodes. So data transfer nodes are basically, they are just Linux boxes that you've installed Globus Connect server on. Globus Connect server is the software that connects your system to Globus. And the data transfer nodes are the computers on which Globus Connect server runs. You would connect to your data transfer nodes in the Science DMZ. That's why these two things are right here side by side, because you want your data transfer node to be in a Science DMZ. If it's not, and you put your data transfer node behind your institutional firewall, you're going to find that your transfer rates are very slow, and very likely your network administrators will call you up on the phone and say, hey, I see that you are doing something really massive through my firewall and it's triggering all kinds of alarms and alerts, and I need to know what you're doing. Let's talk about this. And that's when you would probably go to them and say, hey, maybe we could set up a Science DMZ so that we don't have that problem anymore. A lot of campuses already have Science DMZs. A lot of research laboratories already have Science DMZs. So if you don't know about this, if you are a researcher and your job is just to build the web portal, it's very likely that such a thing already exists at your institution, and all you have to do is find out who knows about it and where the data transfer nodes are that you can use. In particular, if you already have Globus at your institution and you know that, if you're at one of the 120 or 130 or so institutions in the United States, or the, I think there's something like 500 institutions around the world that have Globus installed and set up and ready to use for researchers, you probably already have a Science DMZ and it's already been sorted out for you. Okay, so what's the software look like? Down here on the blue stuff, Globus Connect is the software that runs on a data transfer node, which is located in the Science DMZ. Globus Connect is the software that basically tells Globus in the cloud, running on Amazon Web Services, where your data is stored. And it also configures who is permitted to access it. You know, who are the people who have accounts on the system, and if you've allowed it, who has the data been, who has certain directories within your storage system, who has it been shared with, who might have accounts in the Globus system, and not necessarily on your system, but in the wider Globus ecosystem. So Globus Connect is the software that allows data to move to and from your system. The Globus platform, that's the 5 APIs that I referred to earlier: auth, groups, transfer, search, and flows. That's what we call the Globus platform. So basically, those are APIs that you can call. They're RESTful APIs. So if you know how to use RESTful APIs, you have everything you need in order to use these Globus APIs. And they will interact with, what did I just do? There we go. Okay. They will interact with the Globus Connect software on your data transfer nodes to move data to and from your system, or they will create a search index for you, or create a group for you, or they will run a flow for you if you call those particular APIs. Okay. Then the final piece is this thing called the Globus Portal Framework. So this is the Django Globus portal, or the Django Globus portal framework. If you look at the GitHub repo, it's still called Django Globus portal framework. And that basically is the portal that we have developed that uses a simple data set. It uses a search index. It has Globus Connect, a Globus Connect collection set up. It's all kind of canned and ready to be used. And then it can be customized by you to use your own Globus collection, your own Globus search index, and potentially your own automation in order to make it do what you need it to do for your research. So those are the elements of the Modern Research Data Portal. I'm going to tell you a little bit about some of the detail. I'm not going to skip right over that. Well, yeah. Okay. So Globus Connect, one of the pieces, that was this piece right here, is the software that runs on your data transfer nodes, makes your storage system a Globus endpoint, and also allows you to set up all the authorization for people to use it. So who's got accounts on the system and who has data been shared with. Something that you may not be aware of is that Globus Connect has something called storage connectors. Storage connectors allow Globus Connect to access data in a whole bunch of different systems. So not just the data that's on your data transfer node or the storage that you have mounted on your data transfer node, but also cloud storage like Amazon S3, Google Cloud, Microsoft OneDrive. So all these various, let's see, Box, Azure Blob Storage, all the major commercial cloud storage that's out there. Also, a number of on-premises storage systems, IBM Cloud Object Storage, Spectrum Scale, Wasabi, Ceph is an OpenStack object storage system that you may have installed in your own data center. If you have a Hadoop system, if you have a Lustre system, all those can be accessed using a storage connector with Globus Connect. So Globus Connect is a pretty powerful piece of software. And so don't feel that just because your data is in the cloud, you can't use Globus, because with a storage connector, you can. You can use the same Globus transfer API to access the data that you have in S3 or in Azure as you do the data that's in your local on-premises storage. I wanted to put up one picture about the Science DMZ. Again, if you're not a networking person, you can probably just close your eyes for a minute and pretend that I'm not talking. But if you are a networking person, this might be helpful for you to understand what I'm talking about when I say Science DMZ and bypassing the firewall. It can scare people. So normally in your system, at a university or a campus or a research laboratory, you have both a border router that connects your institution to the wider network, the wide area network, and you have a firewall. And the firewall has rules about what kind of data, what kind of connections can be made between systems back here on your campus or in your research lab and the wider network. So it says things like, oh, anybody can browse the web. Browsing the web is fine. We'll let anybody here do that. But we won't let people from the wider internet come to web servers on campus without our permission. We have to know about all the web servers that are on campus, and we have to set up rules that allow them to be accessible. Otherwise, people on the wider internet won't be able to see things that are set up here on our campus. Similarly, you won't be able to, from the wider network, see I don't know, personal workstations that have sharing turned on, file sharing, because that would be horrible from a security standpoint. So the firewall does a lot of things to make sure that people who are back here on your campus are not exposed too much to people who are over here in the wider network, which includes hackers and scary people. So anyway, the problem with the firewall is that it's slow. There are so many rules, so many access control rules, and so many protocol rules, and this is allowed and that's not allowed, and this is allowed in this direction, but it's not allowed in that direction, and all of that, that the firewall is really slow. And so if you put a Globus Connect data transfer node back here, you would find that you would not get the data transfer speeds that you would expect. And so what we recommend for a Science DMZ is that instead we use the border router to go to a Science DMZ switch or router that has very, very specific rules on it that say, okay, we're going to allow Globus data transfers to go through and nothing else. So basically, it would be impossible for someone to, get to a web server back here. It would be impossible to get to somebody with their Windows system with file sharing turned on or anything. The only protocols that's allowed through here is Globus. And then you can put your data transfer nodes back here. You can have multiple data transfer nodes if you really need that kind of throughput, and you can get tens or hundreds of gigabytes, probably actually even, of bandwidth through this without it getting stuck in the firewall. So basically the idea is it's just a custom entry point to your mass storage system in your institution. And it's a way of setting up Globus so that you get really good transfer speeds. So that's why we recommend a Science DMZ. That's pretty much all I want to say about it in the tutorial. And if, again, you probably want to engage your networking team and your campus storage people if you think that you might not already have a Science DMZ on your network. Okay. Before we move on, I also wanted to put in one more piece of information about Globus transfer and an important feature that you want if you're going to be using portals. You need guest collections. Guest collections make using Globus with portals and science gateways so much easier. The authentication that you do is simpler, and you can use what are called service accounts in order to manage the storage that your gateway has been granted by your campus or by your institution, or that you've granted to your application yourself. I'm going to show you, let's see if I actually wanted to stop for a minute and show you how to set up a guest collection and how to permit an application to have permissions on that, because I think it's helpful to see A, how easy it is, and B, that Globus has this ability to give permissions not just to people, but also to portals, science gateways, applications. So basically, there are a couple things you're going to want to do. One, you're going to want to give your Science Gateway access to data that's in a guest collection. So basically just data access permission. Another thing that you might want to give your portal permission to do is to set permissions on the collection to give other people access to the collection. So other people being people who are using your gateway, people who are logging in using Globus, you want to give them permission to the data that's in your storage. And you might want to only give them read access so that they can download things using Globus, or you might want to give them write access so that they can upload things using Globus. Okay. And then finally, you might want to give your gateway roles that allow it to do things like manage the tasks, transfer tasks going to and from your system. For example, you can make it so that your gateway can monitor all the transfers that are happening to and from the guest collection, and look for bad things, like maybe a transfer that's been going for a very long time, or a transfer that seems to have errored out for some reason. It stopped, and you need to find out why. You can make it so that your gateway has the permission to monitor all transfers to and from the guest collection and flag things that are unexpected. So I'll show you how to do that. So I'm going to switch briefly to my web browser. Whoa, okay. Let's see, where am I? Okay, so here I am in Globus, in the Globus file manager. I hope that for most of you, using the Globus web application is familiar. If it's not, I apologize for that, but I'm not going to go back and kind of give you an introduction to Globus, the web app. What I am going to do, though, is show you how to create a guest collection and show you how to give permissions to a guest collection to your application or your Science Gateway. So I've connected in the Globus web app to Purdue University's Anvil system, which is part of the National Science Foundation's Access system. I have an account on Anvil. And it basically, they gave me a little directory that I can put things on. I'm not very much storage, and I'm not allowed to submit jobs or anything like that, but I do have some storage. And I went ahead and I created a directory. You just do that by hitting this button here that is the folder. And I'm going to say new gateway folder. So I just created a folder. That's going to be where my gateway is going to put all of its data on Anvil. Okay. Right now, me, Lee Liming, I'm the only person who has access to this folder. There's my Science Gateway can't access it. My research colleagues can't access it. People who log into my portal can't access it. So what I want to do now is I want to set the permissions so that other people are able to access it. The first thing I have to do is create what's called a guest collection or a share. So you go to this share icon over here on the right-hand side with this folder. Well, no, actually, I want to go into the folder, new gateway folder, and click the share button. And what it's going to do now is it's going to say, you don't have any guest collections on Anvil. Create a guest collection to set permissions for others to access your data. Hot diggity dog. That's exactly what I want to do. I'm going to click on add a guest collection, and it brings up a little form. I have to give it a name. So basically, I'm going to give it a new name, a logical name. Notice that right here for directory, it has the path to my new gateway folder. Okay, so I'm not giving permissions to my home directory. I'm giving permissions to my folder that I created under it. And I'm going to call it something like Science Gateway Data Access. I'm not going to put anything else in. Normally, I would put in a description that makes it easier for me to find and so on and so forth, but I'm not going to. I'm just going to create it. The next thing it brings up is the permissions page, because right now, even though I just created a guest collection, I'm still the only person who has access to that guest collection, because that's the default. The default is Only I have access to it. Access Purdue Anvil, that's the administrators of the Purdue Anvil system. They also have access to it, of course. And Globus is letting me know that, but I'm the only other person right now who has access to this. So I need to add permissions. Now, permissions are basically just read or write access. Okay. So I'll show you. You could either, you have to have read, otherwise they don't have any permission at all. You can set write or not write. It's up to you. And I can share with a user, an individual person, a group. So in other words, anybody who's a member of a group, I can make it so that it's available to everybody as long as they're logged in. I can even make it public, which means that it's available to everybody, even if they're not logged in. And you might say, well, how would somebody access something using Globus if they're not logged in? The answer is that I would give them a download link. I would give them an HTTPS link, download link in my portal. I would expose it. They wouldn't do it using the web app. They would only do it using my portal. I'm not going to do that, though. I'm going to make it available to a particular user. But I'm not actually going to give it to a person. I'm going to give access to my portal. Okay, so the question you should be asking is, Lee, how do you give access to an application? The answer is that you register your application at developers.globus.org. So actually, let me just very quickly go to developers.globus.org. It's a page that you get to. You can register a new application with Globus. And I've already done that. So it's not, normally it would make me log in. And then it allows you to create projects, and then within projects, it allows you to register applications. I registered this application already called Lee's Globus Portal. Okay. And when you do that, you get a client ID, which is just a long string of numbers and letters. And you can generate secrets. It doesn't show you the secrets after you've created them once, but I can generate a second secret, generate it. And now this is essentially the password. So up here, client ID, that's the username. And this down here is the password. And I can use this in my web portal if I want to authenticate to Globus. And then I'll have access to anything that this client ID has been given permissions to. So let's give it some permissions. This client ID identity username right here, client identity username, this is the username that I put into the Globus web app to give permissions to this application. Okay, so I put it in here where it says username or email. Add. I'm not going to send any email because there's nobody to send email to. It's just an application. And I'm going to give it both read and write permissions because I want the portal to be able to put data here as well as get data here. Okay.
Lee, can I ask you a quick question?
Yes, you may.
On the public one, you said that when it's public, you can give a link to anyone who has that and they can download.
Yep.
But what does the write permission then on that give? Does that mean they can upload with that link as well?
You're asking if you give write permissions
to a public.
I don't know that option is even, we'll have to go back. Let me finish this up and I'll go back and we'll take a look at it. Okay. I think you might not be able to give public write access, but I'm not positive. Okay. Hang on a second, okay? So notice now that my permissions list has me, Liming at accessci.org. It also has Access Purdue Anvil, that's the Anvil system administrators. And it also has Lee's Globus Portal, which is the client ID from my client registration. I have given my web portal that can now use this username and the secret that was displayed over here. If I leave this page, I'll never see that secret again. So I have to write it down somewhere. But I'm actually not going to use it, so I'll just let it go. My portal now has read and write access to that folder, the Science Gateway Data Access. I'll show that to you in just a second. But that's not all I want to do, okay? So I've just given it the ability to move files to and from that location, okay? In addition to that, I also want to give it a role, okay? Roles allow things to change permissions. So I want my portal to also be able to add and remove permissions on this, this storage. So I'm going to assign a new role. I'm going to paste that client ID in again. And I'm going to give it the access manager role. View, add, and delete all access rules on the endpoint. It implicitly gives read and write access to the root of the endpoint. Okay, so basically what I'm saying is now my portal will be able to add and remove permissions for other people or groups. Oh, and it wants me to log in again. Okay, well, I'll do that. I'm game. Let's just make sure that it works properly. Yeah, I didn't even think I would need to do that. Okay. Okay. Because I already was logged in. Yes, add, access manager, add role. Okay, so now my roles show that Lee's Globus portal now has access manager permissions on that thing. And I'm going to go back to the overview tab, and I'm going to open in the file manager. Try again. Right, okay. Notice that when I go there, the collection changes to Science Gateway Data Access, and the path looks like just tilde. That's kind of weird. Basically, this is a guest collection. You have no idea where the home directory is or anything like that. All you know is that this is the storage that was granted. And so I would have to go all the way back to Access Anvil in order to go back and see that it was really the new gateway folder where that was done. So that's basically where the permission is. If I'm in now new gateway folder and I click share again, it'll show that, oh, there's a guest collection. The guest collection is called Science Gateway Data Access. Let's take a look at the permissions. Here were the permissions I was looking at. And then let's answer Mona's question. Okay. All right, so Mona's question was, if I do add and I do public anonymous, oh, you do, yeah. So basically this would be a public Dropbox. This would basically mean that if the person can get a web link to the folder, they should be able to upload into that folder using their web browser, okay? I don't think that we actually have, I'm trying to think if we really have a, yeah, okay, I know how you would do this, okay. All right, so the way that you would do this is I would go back to the file manager. I would go into that guest collection. Here it is. I would open it in the file manager. Okay, so now this is the view. This is my view of the guest collection. Notice that there is here an upload button. Okay, if I were to right click on that and do, where is it? Huh. Normally you're able to copy the link, aren't you? Well, what happens? Oh, okay. I'm trying to figure out how to get that upload link. Let me see. Maybe if I do this, access this collection and path in the file manager, access the select file. Nope, that's not what I want. I really want upload. It will, I know that it will normally ask me to log in again. Ah, there we go. Okay, so you click that upload button. Still doesn't give me a copy link. Select files to upload, select folder to upload. Can I do that?
Although then in your setting, you didn't enable write in the
Oh, I think I
permission.
did.
Oh, did you? Okay.
Pretty sure I did.
Okay.
Let's see, hang on a second. I'm pretty sure I did. Permissions.
Hey, Lee, can you share the actual the URL to the collection down to the guest collection? Would that be shareable with somebody? That's what I'm thinking.
That's what I'm trying to do.
Okay.
I'm trying to share an upload link.
Gotcha.
And I'm having a hard time getting the web app to give me the upload link. I can do it in the web app, but of course I'm logged in right now. And the point was, how can you make it so that you don't have to log in order to upload? And I think, let's see, select files. If I click on that, oh, it just takes me to my browser, or my browser lets me do that. I really want this link. You know, Mona, I don't know that that's possible at the moment. And I don't think it's because I don't think it's that Globus Connect doesn't let you do it. I think it's that our web app doesn't let you get at the link that you need in order to do it. But once you got that link, you would just email it to somebody and say, here, click this link. It'll let you pick a bunch of files and it'll upload it to my collection. And they won't even have to log in.
Okay. So this is using the Globus HTTPS feature, right?
Exactly. This is using Globus's HTTPS access. Yeah.
Yeah, I think
Yep.
there should be a way to get that link.
Yeah, it's
Interesting.
even easier. Of course, I made a guest collection for the directory that didn't have anything in it. Anyway, bottom line, I want to get back on track here a little bit. I did show you how to set up a guest collection for Science Gateway use. And it's important that you understand that basically, unless you do this, unless you register your application, get a client ID in secret, and then give permissions to that, whoa. Oh, that was my share button. Okay. And then give permissions to it. Your gateway will not have permissions to the storage itself. So you have to do that first. And then if you also give it access manager permissions, like here, you can use Globus SDK, that's the software developer kit, API calls to give permissions to your portal users so that they can upload and download files. Okay. And just so you know, this is a little note just specifically for Mona. Mona, you did this in the Cosmic Gateway using the older version of Globus Connect software. I did it using the newer version of the Globus Connect software. And I did that on purpose because I knew you would be here and I wanted you to see how it works with Globus Connect version 5. Okay. You do that. Again, you have to register your application, get a client ID and get a client secret, and then use this client identity username here to give permissions to the application. And then after that, basically everything works the same as it did with the old version of Globus Connect, but you don't have to worry about any of those X509 certificates or anything like that anymore. It's all done with OAuth. Okay. All right. Finally, let's take a look at a real Django Globus portal and see what it looks like. This is putting together everything that I've spent the last hour and 20 minutes talking about, putting it all together into the actual Django Globus portal framework, which is the code that we're going to be working with for the second half of this tutorial. So very quickly, I wanted to show you this is a real portal that's being used by real scientists. This is the ALCF or Argonne. Let's see, what does ALCF stand for? Argonne Leadership Class Facility, I believe is what it stands for. It is Argonne's supercomputing facility. And this is the ALCF Community Data Co-op. It has a really cool acronym, ACDC. So rock and roll, everybody. basically what we have done for the advanced, for Argonne, is we've created a number of portals. Each one of these 8-9 portals that you see here is built using the Django Globus portal framework. What did I do? There we go. Okay. You'll see that most of them are private. A couple of them are search only or public data. I actually have permission to, I am logged in. There's a login button at the top. I'm logged in as myself at University of Chicago. I have permission to the XPCS portal, and so I'm going to show you that one. There's also the materials data facility, which is another interesting one we'll take a look at, and the DL Hub, which is a model repository for machine learning models. So basically, it's a way for researchers to publish their machine learning models. The APS XPCS portal, that's a lot of acronyms. APS stands for the Advanced Photon Source. It's Argonne's very high-powered X-ray microscope. And XPCS is one of the research teams that uses the Advanced Photon Source. And they run samples through the Advanced Photon Source, generate data, do some analysis of that data, and then they publish the data, and they publish it here in this portal. And the permissions are, so basically they have researchers who come to them, to the XPCS team, and they say, hey, I'm going to send you a sample. Will you run it through APS and then publish my data for me so that I can do something with it? And they say, sure, you can do it next month. We'll run your sample on, say, I don't know, November 13th or something like that. Make sure it's here by then. And so they send it in. The APS people run the sample through. They do some preliminary analysis on it, and then they publish it in this portal. So I'm not going to show you how the data gets published in the portal yet. I'm just going to show you what it looks like once it's in the portal. So once you're looking at one of these Django Globus portals, you will see, this is a search box up here. It's kind of hard to notice because it's so big. But basically I can type in search terms here. This is just garbage. I have no idea what I'm typing right now. But you can put in, keywords here if you want to, or you can use the search facets that have been helpfully provided over here, which use the metadata that was that the data was published under, like when was the sample run through the APS, what date was it? If you know that, you can just click on a date and get narrow things down, or let's see, what am I looking for? Person, there we go. We give researchers their own parent folder. So if you want to find, only ones for you, you would click on your name there. Oh, that's interesting. I don't have permission to his data, I guess. Remember, I told you that this can all be based on permissions. That kind of surprises me that I don't have permission. Oh, okay, well, maybe that's not a good example then. But what I usually do is I go in here and I find a recent date. Oh, I see. Yeah, I already had this thing clicked right here. So there probably weren't any. Okay, anyway, if I wanted to look at August 21st, 2022, there were 2,580 data sets that were processed that particular day. And here's my results. And you'll notice that down at the bottom, it has pages that I can go through. There are 200 pages. I forget how many listings 50. We list 50 at a time. Each of these things is a data set. This XPCS portal has been customized a little bit to do previews. So they're actually previewing things that are, in the data set, in the search page or the search result page. And so you get the scattering pattern, which is helpful for people who are using the Advanced Photon Source to figure out, did it scan right? Or, was there something just totally wrong about the way it scanned? And this is not something I want to use in my research. These curves right here tell them what they're looking at. They don't mean anything to me at all, but they mean something to them. And similar, this plot right here shows intensity versus time. And I don't know what to do with that either, but it's meaningful to the scientists. And then it shows a bunch of the data that's in the search index for this particular data set, so that they can look at it and make sure they're looking at the right thing, make sure that the APS was set correctly when it was scanned and all of that. And then they have some extra customization stuff down here. Just tons and tons and tons of stuff. All this stuff is stored in a Globus search index that XPCS uses. And every time they run a data set, they make a new entry in that index that has all this information in it, all this metadata. And then up at the top are the pieces that are Globus related. You can transfer or sync the data. You can download this particular data set using HTTPS, using Globus, or you can get a link that you can then share with other people to this particular page. Of course, they have to have permission. But basically, this is kind of what the portal does for you, is it allows you to see what is available via the portal. You can do keyword searches should you want to, or you can search by facets that have been configured by whoever runs the portal that make things easier to find for people. Let's see, this is only the most recent cycle of the APS. 2 dates, 76 data sets. I just wanted to make sure that I'm looking at something fairly recent. And just so you know, these plots that you're seeing are actually stored in Globus. They're stored on a Globus endpoint. And we're using the HTTPS interface to bring them into this portal's display. So basically, this is a Globus HTTPS link that is being used to pull the plots off of the Globus endpoint. And all of the fields here, the data here is coming out of a Globus search index. When you click on transfer or transfer and sync, you are taken to Globus. And it basically takes you directly to the directory that has the data for that particular data set. And then if you want to, you can open up a second panel and find your own place where you want to send the data and do a transfer. I'm not going to do that because this is technically private data. I don't want to make a copy of it for anybody else. And let's see what else. If I go back, take me back, please. Oh, we made it. Oh, I see. We made it so that it opens up another window. Okay. If I download via HTTPS, it will probably ask me to log in again. This is Globus doing this. Oh, good heavens. Wow. Yeah. Okay. Hang on a second. And then what's it doing? It's thinking really hard about something. Hopefully it's thinking about whether I really should be downloading this or not, because I think the answer is probably no. In fact, I think before it has a chance to figure out what it's doing, I'm going to close that. I didn't really want it to download. I just clicked the link. And then get link allows you to copy a link to the clipboard. So that kind of gives you an idea about what our portal does. This is what the Globus, the Django Globus Django portal? No, Django Globus portal does. And everything else for the rest of this tutorial is all going to be about deploying it for yourself and then customizing it to use your own data. Where are we now? We are at about halfway through. I would like, normally we would go to a break right now. We're running a little bit late, but instead, I want it really, I promise you, will not take Steve very long to show you how to deploy this in your own tutorial instance. And so we're going to do that before the break, and then we will come back and talk about customization. Okay, I'm going to stop sharing. Are you ready, Steve?
As ready as I'll ever be. Let me share my screen. I'm going to go through the slides here fairly quickly because the meat of this portion is really to kind of do a quick hands-on, SSHing, signing into your VM and running commands to actually bring up a portal. Lee already talked pretty extensively about the MRDP, that design. At the heart of our portal here is Globus Search. We have an input form, we're extracting information and then ingesting that information into Globus Search. That can be done, any number of ways through the API, through the SDK. And I will show you some ways later on of how to actually ingest data. So this is just enabling discoverability through the MRDP and a faceted search. So the core functionality of this portal is what? So user authentication at the top. And then we have this extensible modular framework in Django that's built on Python. Open source, can really be used for almost anything. Doesn't have to be a science portal. It can be any kind of web application you want to use it for. Within that framework, we get lots of different things like portal URL mappings and token loading. We're going to be making service calls to Globus Search, managing that request lifecycle, and then process those search requests. Authentication, scopes are configured within the portal, and you'll see some of that in the code that when we sort of move through this. Users are authenticated with Globus using that standard sort of auth flow. We use Python social auth for that authentication. We actually have a Globus backend for that authentication, Python social auth. The tokens themselves are saved in the database for easy access. And those future requests can use those tokens that are stored. And in our case here, we're going to need scopes for search and transfer within our portal. I know I'm going fast, so please stop me if you have any questions here. We're making those service calls using the Globus SDK mostly. We'll load a token from the database. We'll instantiate a service object with that token. So that could be a transfer service or a search service. And then we'll make calls to Globus with that service and render those results in a template. The URLs span three categories: index selection, an index search page, and a search subject detail page. With Django, we can add to those URLs as we need. For now, those are the three sort of default URLs you're going to get out of the box when we bring up this portal. It can support multiple Globus search indices. So in our settings files, we can have as many search indices as we want in one portal. Each subject has a unique URL when you add those search indices. This is an example of what a search URL pattern might look like within your Django project. It's just a path indicating what the path is. So this top path would be, let's say, like a home level type path. That's your index selection view. And then so on and so forth. Then you have your index detail, which is a search view. And then even drilling down to a subject, you have a detail view here as well. Okay, so an index is configuration driven. We are going to configure that index in the portal itself. We're going to add that search index. It's more or less a UUID that you add. Name, facets, fields, and we can start searching from there. Lee already touched on a lot of this, so again, I'm going a little bit quickly through it. Let me see. Go back here real quick. Lifecycle requests, user makes a query. The portal sends requests to Globus Search using a bearer token. The portal receives a response. It does the processing. On the response, we can parse dates, build URL for Globus web app, renders the data into templates, and the user receives that search page. So a typical sort of HTTP type exchange of requests there. Okay. So here is the more hands-on portion of this. Creating your science gateway using the Globus portal framework. So I relinked the bit.ly link here. I'm going to come out of that view so I can move back and forth here a little bit. The first thing that you would want to do, and you can do this if you want now. If not, as we go through the portal setup, will want to create client IDs and secrets in the Globus web app. There are defaults. So you'll see as we go through this, you can have a default for the client ID and client secret. If you want to go in and create your own, it will look something sort of like this. You would create a project, and then within that project, you would add a new app. That app would then give you a client ID and you would generate your own secret from there. And then we need redirect URLs in here to redirect from the actual authentication piece of this. Python social auth, like I said, we were using before, have default structure of URLs for the lifecycle of an auth request. In this case, we're going to add a redirect URL of touch one. This is my particular space within AWS. You would add yours, whatever you claimed in that spreadsheet. So 2, 3, 4, and so on. We're adding the port number here. This is our secure port that we're running. And then to complete it is just complete -Globus. That's where the redirect is going to get sent back to the portal to actually process that request. So feel free to create your own client ID and secret. Again, you don't need to. The portal process setup is going to do that for you. So let me go back here. Okay, so this is where we're going to start actually logging in and SSHing into our portal here. So what I'm going to do is I'm going to, in the that bit.ly link, under developer tutorial exercises, under portal deployment exercise, you would click on this. And this is going to give you the commands necessary to run on your VM to bring up this portal. So what I'm going to do is hopefully I can do this. And I'm going to open my terminal. So now we have my terminal on the right side and my my commands on the left here. I'm going to blow this up a little bit so you can actually see it. Okay, so this is the point where you would SSH and log into your VM. So my VM is on the right-hand side here, dev1. If I log in here, it's going to ask for that password. So that password is so here we go. We are now logged in to our portal, and we're going to start running some of these commands here. The first thing we want to do is activate our Python environment. The Python virtual environment is just sort of separating this particular application's environment out from the rest of the environments on the machine. So most of these, I mean, pretty much all of these, you can copy and paste. So we're going to source that. And you'll see here, once it's sourced, you know in your virtual environment when you see it next to your login here. So we'll just make sure that we have everything we need installed here. This is of interest right here, Cookie Cutter. Cookie Cutter is a way of really grabbing and deploying almost any kind of application. In this sense, what we did was we built a default way of creating these portals through Cookie Cutter. If you want to visit this, we can take a look real quick. There's instructions about how to run this. And I wanted to look at the code. There we go. So this is structured as a Django project. So this is what you're going to be essentially cloning when you run Cookie Cutter. So let's go back to the tutorial here. This is the meat of what we're going to be doing here. So this is the easiest way to bring up this portal is to run Cookie Cutter. We can keep the default here, project name, we'll just keep it as Globus Portal. The project slug is going to default to whatever your project name is, with Django prepended to the actual project. That's Django convention is to have that Django word before the rest of the project name. So we'll keep that. We can keep the default description here, put anything you want in there. Let's update this. We'll put in my Globus username. Version's fine. Okay, so this is where the client IDs are going to default. So this is the client ID you saw right here. The F44. This is specifically built for this tutorial. And then I have a default secret, which is one of these. And then the search index is also default. You'll see what this default search index is actually searching. The portal endpoint that is associated with that search index. So this is the collection that we're going to be viewing. And that's it. So if I do an ls here, you'll see that I now have a Django Globus. Is that what Django Globus? Yeah, Django Globus portal. For some reason, I thought I called it that. So we can change directory into that portal. It's actually a little bit easier. Let me see here. If we do this, because then we have easy reference to this through a environment variable. We already changed the directory into that project. So now we have to install a couple of requirements here. So the nice thing about Python and Django is that it allows us to add modules to our application. That's what this is doing here. So it takes maybe 30 seconds or so to run through. Okay, since we do want to run this in quote unquote production mode, we are going to edit this settings file. So I'm going to change directory into where the settings file are located. And that's usually the project slug / project slug. And we'll do a list on that. And you see the settings folder in there. So I'll change to settings and list that. You see we have a couple of different settings files in here: the base, local, production, and search. Right now, we're really interested in base, local, and search. Let's edit the base. I'm hoping you're somewhat familiar with Vim or VI. And we're going to find installed apps. So from here, we're going to add Django extensions. We'll save that. Then, after we do that, migrate. And I think I'm in the wrong directory. So let's change directory back to the base directory and just make sure we have access to our commands. Yep. Migrate is a Django related script that's going to sync up your database with your models. So there's some default models in there that will sync and create a SQLite database. We're good there. A collect static is going to take all of our static files, our JavaScript files, our CSS files, our image files, anything like that. It's going to gather that within the project and put it to the central location that it needs to be served out from via Django. Collect static. So we had 219 static files copied to static and 673 post-process. So we should at this point be good to run server. And if we cross our fingers, we should be able to. So there, we've just brought up that portal. This particular portal is searching some example data from NASA's Earth observing system. I don't know anything about the system itself. It's just some example data that we decided to grab onto that is easily searchable. So if you see up here, if I expand this a little bit so you can kind of see, you'll get the login here. It's going to ask me to log in, or if I'm already logged into another account, it's going to find that in the sessions and log me in under UChicago, which I'm already logged into. If I click on Terra, here's the facets for this particular search, location, dates of the search, orbit group, subjects, and contributors. If I drill down here, I can see the metadata associated with this particular detail, the particular subject, I should say. And I'm presented with all those same links, excuse me, as before. So we have transfer sync, download via HTTPS, and that get link that if you could copy and paste this and send it to people that may or may not need it. Let me see, I think that's about it for this. I can pause for questions here. I'm going to show you some more things associated with this transfer and download and get link a little bit later. There's an issue with this particular data set that if I click on this, the metadata is fine, but you see a directory listing connection failed. The particular collection and endpoint is down right now. We do have one that is up, and then I'm going to show you a little later on in this tutorial. But for now, this is what we bring up. After I think the break, Lee is going to show and demonstrate how to update this and add either another or an additional index and switch your search and facets around as well as your templates to show a different search. So this is what comes out of the box. From here, as the developer, you would go in and you would edit the actual Django project and make it yours. So I'll pause here. I know I moved fast and there's a lot going on here, so I'd be happy to answer questions. And Lee, if I missed anything, let me know. I'd be happy to circle back and touch on that. But I think I got everything as far as creating a portal goes.
So this gets you to the point where you have a portal running. It's using our data from our data collection and the index that we created by scanning the data and publishing stuff into an index. And the next step after our break will be to show you how to make this show different data that you provide and that you index. And then you can see how to change the search facets and what displays on the search results pages and all that kind of customization stuff. But we're going to save that until after the break. I think we'd like to take a 10-minute break. I'm showing 5 minutes to the hour right now. So let's go ahead and come back at 5 minutes after the hour. And we'll go ahead and show you how you would take this portal that you brought up and have it use a totally different search index and a totally different data collection that works with your data. So 10 minutes.
Thank you.
So this is the portal that I deployed while Steve was going through. So it's exactly the same as your portal and exactly the same as Steve's portal. This should be basically what all of us have. It's the defaults that you get when you deploy a new Django Globus portal. Notice that when I look in the search screen, I see an index that has things like locations and dates, orbit groups, the specific orbit, subjects, and contributors. Those were the search facets that were configured in the default for the Django Globus portal, for the default deployment of the Django Globus portal. This is a data set that's based on some Earth observing satellite or Earth observing system data. And so it's basically all satellite generated data. What I'm going to show you in the next few minutes is what you need to do in order to reconfigure the portal to use a completely different search index with different data in it that has different metadata and metadata fields. So you can see how easy it is to use this same portal framework with a completely different data set and the various pieces that need to be changed in order to do that. So let's see, here we go. So if you go back to the, I hope, oh, that's the wrong place. If you go back to the cheat sheet page, the globusworld.org/com/tutorials, that's that bit.ly link that we had. One of the things that is linked off of here is, let's see, code for the cookie cutter deployment is in this GitHub repository. That's not what I'm looking. Maybe it is. Nope, that's not where I got my cheat sheet from. Okay. Anyway, my colleague Vas Vasiliadis has put together a nice cheat sheet for this at github.com/vasvtutorials. And there he has information about setting up the portal, but then he also has a nice little cheat sheet for the specific files that need to be changed in order to switch you over to a different setting. So I'm going to be following those pretty closely. The first thing that you need to do to reconfigure the Django Globus portal to look at different data is to change the search.py file in settings. So I'm going to go back to my my tutorial instance, and I'm going to cd to that directory. Oops, that's not a directory. Right, I do this every time. That's a file. Okay, I'm going to cd into that directory. There's a directory called settings, and in it there is a file called search.py. Let me show you what's in there. It's not very complicated. The very first thing it has at the top of it is in this search indices data structure is a UUID. That is the UUID of the search index in Globus Search. So in the Globus Search API, you have to specify a UUID for the index that you're using, and everything, all of your searches and everything will be done against that index. Well, this was the default. This was the default index that we were using that had all the NASA Earth observing satellite stuff in it. And you'll notice down here, location, dates, orbit groups, orbit, subjects, contributors, all that stuff is in here. Well, I have a replacement for this file called search.py.new that I got that has different stuff in it. It has a different UUID, so we're using a different Globus search index. And then it has different fields. It has, instead of the orbits and things like that, it has a title, a URL, let's see, no, these are not things I'm looking for. It has names, it has years, right, years, and survey number, and I can't remember what else. Those are the two facets that we're going to be getting with this. I think when we look at the fields file, we'll see all the rest of the fields show up there. So anyway, what I'm going to do is I'm just going to copy over. Actually, first thing I'm going to do is I'm going to take down my portal, because my portal is running in the background right now, and I'm going to foreground, and I'm going to Control-C out of it so that my portal is no longer running. So I just took my portal down, and now I'm going to copy the new search.py file over the old one. I've already made it. Notice that I've already made a copy of the original called search.py.orig. That's so I can always back out of this if I have to. So there, I just made a new search.py that has the new search index and new facet information in it. The next thing I'm going to do is go to the fields.py file. Let's see, which is in this directory. Same setup here. I have a fields.py, which is the current Earth observing satellite one. I have a new one, and I have a copy of the original one. So let me show you what's in these. In fields.py, this is the old one. File name, dates, let's see. There's a bunch of stuff in here. No, yeah, that wasn't actually with it. Okay, that's not particularly useful. So let me copy over fields py new over fields.py. Okay. The next thing is that basically is telling the portal what fields to look for in search results, so that it pulls out all the fields from the whenever I do a search with the search API. It will come back with a whole bunch of metadata, and I have to know what fields to pull out of it. The next thing is going to be to change templates. So Django is template driven. Everything in Django that you see gets generated or filtered through templates. And there are templates for the different pages or different views in the Django Globus portal. This template that we're going to be changing here is the detail overview. So this is basically the overview of the details page for all of our search results. I'm going to copy and paste that path. Make sure I'm in the right place. Yep, detail overview. Let's take a look at the original detail overview.html. This is Django template stuff. So it's basically HTML with templating in it. And what am I looking at here? So basically there's going to be a general info heading. And then, I think what I remember was that this new version is basically just going to dump all the metadata that's available for the files. We'll see how that looks in just a second. Let's copy the new over the original. And there'll be one more. Oops, I think it's down actually. Yeah, it's down a subdirectory. There's also a search results template. So I'm going to change the template for search results. Search results. Yeah, okay, this was the one I was thinking of. This is where it shows location, date, orbit path, orbit count. So this is the original version, and the new version looks like this. Aha, no more orbits. Now it's latitude, longitude, altitude, attitude. No attitude. Latitude, longitude, and altitude are going to be the things that are going to be displayed in this one. So let's make sure we make that copy. Copy the new search results template over the old search results template. Okay. Now I have changed all 4 files that need to be changed. So basically I changed 2 Python files and 2 template files. And I should now be ready to restart my portal and take a look at it. So let me, hopefully I have that command somewhere. Oh dear. It's been a while since I ran that command. There we go. 71. So command number 71 was, oh, whoops, I'm in the wrong directory. Okay, Django, I need to be in the directory that has manage.py. Let's fire up that, oh no, what did I do? Fields is not defined. That's not good.
Lee, did you update your fields file? I think there's.
Let me just double check. It's possible that I skipped that one. Oops, I want this directory. I don't know, it looks pretty good, doesn't it?
Yeah, it looks good to me.
Year, GPS, latitude, longitude. And this is the, yeah, this is the field. Okay. So these are our new fields right here in this.
Lee,
Yeah,
top that overrides where
yeah.
you have to delete that. That might be causing some issues.
Oh,
That's not really valid Python.
you're right. Well, yeah. Oh my gosh, I wonder if that I wonder if that was true for all of those files that I just did. Hang on. So I'm not running anything. Okay. Let's go back up. Make sure I'm in the right directory. That's what I was afraid of. Oh shoot. Okay, just a second here. Search.py. Yep. Okay. I have a feeling I copied more than I meant to from Vass's examples. I think that I copied that comment at the top. Search.py. Oh, no,
That should be
that
fine.
actually does look okay.
Did you import fields? You did not import at the top.
At the top of which file? This file?
Of the search file.
Search.py?
Yes. You should be able to say import fields, right? Right. Yeah. Right. Anywhere. That's, yeah. I'm hoping that is the correct directory of where we're looking. Because let me double check.
It's not from this field, I know. I mean, that's not where that file was. That file was in a different directory. Shoot, I thought, okay, wait a minute. Let me see what the original had in it. Sorry, everybody. I should have tested this before I did it. There we go. That's what I want.
Yes, that's correct. That should do it.
Okay. Somehow our example got messed up. Okay. Yep. Much better. Okay, we have a portal. Let's take a look at what it looks like now. So here's what it looked like before. I very carefully left this in the cache. So this is what we saw when we did when we clicked on search before. We saw India, Bermuda, China, location, dates, orbit groups, etc. Okay, if I hit reload now, year, survey number, those are our two facets. Yeah, so we changed the facets. And we changed, notice that these are now images. These are all image files rather than data set files that were in the previous portal. So basically, by changing just two of those Python files and two of the template files, we were able to completely reconfigure it to use a different Globus search index. So basically a different metadata index and a whole different schema of metadata that's included there, and then to display it with different facets. Okay, so the whole point of that exercise was to show that you can take this Django Globus portal that comes with this Earth observing satellite data set, and you can make it your own just by replacing the search index that you run against. And you can use whatever schema you choose in your portal, and you can, highlight whatever facets you want in the search. Oh, also, if I click on one of these, you should, yeah. So now we have a totally different set of fields that display on the details page. That was that details template that we changed. The details template was changed to include now latitude, longitude, altitude, file size. This is basically what's in the new search index. Okay, so one thing I want to make clear here, we did not create a search index in order to change this, okay? The search index was already there. All I did was I switched the UUID in the Python file from one search index that existed to a different search index that already existed. So the next thing that we wanted to show you is, how do you actually create these search indices in the first place? How do you make that, how do you populate a search index? Steve, are you prepared to do that? Or do we want to do something else in the meantime?
Nope, I can do that.
Okay, then I am going to turn the baton over to Steve. Stop sharing and let Steve talk to you a little bit about how indices are created, how you create a search index using the search API.
Yeah, let me get back and share, do the screen juggle here again. Okay. Again, I'm going to quickly go through these slides, making data findable with Globus search. So how do we do data description and discovery with Globus search? Metadata store with fine-grained visibility controls. We're going to be creating metadata based off of similar data that Lee just demonstrated. The schemas we create are they're agnostic and dynamic. You can do simple search, a more simple type search. You consider like a get type of request using URL query parameters, and you can get more complicated in your search. Think of it as a post request using a search request document. This is all documented quite well at the search API for Globus. So how do we ingest data? I'm going to use a combination of the Python SDK and API calls. You'll see that in the code that I demonstrate a little bit in a couple of minutes here. So basically, to ingest, we need to create a gmeta list, a metadata list with ingest data. And that data is loosely structured as follows on the screen. You have an ID. A subject typically points to the location of the file or the folder that the file is located in. You can have a visible to. I believe that can be any number of things, public or even down to access. This is where that metadata, where you can protect that metadata. So with this visible to, you can add scopes in there that the metadata is only available to. Here we're saying this is public, and then you have the actual content of that gmeta. And in this case, it's just one entry with a file type of file. We'll have more than that, obviously. So this is a post to this API endpoint right here.
Steve, one thing I wanted to point out, that visible to can be, as that screen shows right now, it can be a group or an identity. So you can make it so that this particular entry is only visible to one person. Mm-hmm. You know, if it's, for example, the person who submitted it and it hasn't been curated yet, or you can make it a group, a Globus group, or you could make it be an application, you know, the portal itself using its client ID, like we did for permissions and guest collections, or it can be public, like the first example was. So this shows you that you can put permissions on the data that's in your index. So you can have permissions not only on files, you can also have permissions on your search data as well.
Actually, so moving past that, let's see. I think these are probably, this is a simple query. So we have an index ID that we know, you know, what the data is, and so we do a simple a query. Here it's just doing a type of file or HDF5 that will bring back a G search result. Again, that has gmeta and then entries within that. This is a little more complicated type search. This is that post request that I was talking about. Whoops, keep going past. And this complex query, you can do filters, facets, boosts, sorts, and limits. Just some basic a basic post search here. So script for ingesting data. So we're going to use both the Globus Python SDK and a few of the search API endpoints. If you want to dive into the documentation for either of those, particularly the API, we're going to use the index create and index delete endpoints. Those endpoints are actually in beta still, but they do work. And I find them very reliable for creating indexes and cleaning them up and deleting them if you need to later on. So let's check. Let's go into back here, and I'm going to bring over some Python code. Make this a little bigger so you can actually see it here. Okay, so just a quick, let me blow this up so you can kind of see it a little bit better. Okay, we're bringing in a couple of things here, notably the Globus SDK, a Python library called requests, which is actually going to be used to call the API endpoints. Really, this is one of my favorite Python, just as an aside, one of my favorite Python modules. It works very well supported. So if you need something in your Python code to actually make HTTP requests, this is a really good one. The data that we're going to be looping through and scanning is image data. And that image data has EXIF data, what they call it's metadata associated with the image. So we're going to be using a plugin called EXIF. It was one of the better metadata extraction plugins I could find for Python. None of them were all that great. This was the best one that I found. And then we need, from the SDK, we need a particular set of scopes, and that's the search scopes. Obviously, we're going to be doing search, so that's what we need. I'm going to be getting the data that I have that I'm looping through is actually on my personal machine here, which is connected through Globus Connect Personal. I have some collections, some directories writable within that file system. I'm going to be using a client ID and secret that I've just been using from starting that Globus portal before. We have a collection ID associated with these files. This, I think I'm going to try to attempt to use this GCP ID over this portal collection ID, since these files do exist at this location. So it wouldn't be wrong to say it, but I might attempt to try this first. And if that doesn't work, we'll circle back to the portal collection ID. Next, I'm going to register a client through the SDK using the ID and the secret. I need to get an authorizer with the client and search scopes of all. I then have a search client based on that authorizer. From there, I can get tokens with the necessary scopes. I can then get a search token from those tokens. Here's the access token. And then I can use that to build an authorization header to then go ahead and make these actual requests to do stuff with the API. A little bit of a hurdle here to actually get down to this auth header, but it's not too much overhead, just a couple of lines of code to get going with the SDK. So I'm going to go ahead. Let me clear here. These are sort of, you don't really need to, these functions you don't really need to worry about too much. They're just some helper functions to massage the data a little bit. So I'm going to copy and paste everything down from the search auth header and just let all that stuff populate in my Python console here. So now we have all the necessary authorization and authentication we need to do in order to actually do things with the API. So let's create an index. So we're using requests to post to this endpoint, and we're sending some JSON along with that post as a display name and description for this index. And then we have to send this search auth header along with it in order to authenticate and actually create the index. So let's do that. Usually takes maybe like a second or two to create the index. Let's print the response from that, because we need to see what the ID is, which is right here. So this is the UUID that we're going to be using for the new index. I'll copy and paste that here like it says. Let's register that with the console. Oops. Okay. Now we loop through the files that we want to ingest and we want to extract the EXIF data from. So we'll do that in a loop. I think we should have 196. Yep, 196 files. Not too bad. That's not too many entries to ingest. Okay, so then we're going to start looping through and actually ingesting this data. So here is our file names that we're looping through that we created above through that function. We're going to split the file name out. I don't even know if we really need to do that, to be honest with you. We would only need to do that if we're going to use the portal collection ID as the subject. In this case, I'm going to use the subject of my GCP ID and a reference to the folder name that these files are located in. I'm going to create just a metadata entry, a sort of stub for it with the metadata ready to be ingested and the subject. I'm going to open each file. I'm going to extract the EXIF, the metadata here. I'm going to build my metadata entry based off of latitude, longitude, and anything else that's located in this, this image list all. I'm going to append it to a data array. And then that data array is going to become my gmeta entry. So I'm going to loop through that data and append it to a gmeta list with the subject. And here's my visible to, and here's my content with the metadata. So then I have a payload and just type gmeta list, which you saw on the PowerPoint with the ingest data of gmeta list. And I'm finally going to ingest it here. So let's do all of that. I'm going to copy and paste everything from here. So that's going to get all of our data ready. I hope. Payload. Yeah. Okay, got a long payload there, big payload. So we're going to ingest that data. Ignore this. That is a bug that I need to bring up with somebody because it actually did ingest documents. As you can see, the success true here. And we have a task ID if we want to go check the task of if you have a large data set that you're ingesting. So now we should have data in there to search. Let's do a really simple search query. It's just more of a get type of request and see what we get. Here we go. So here's one entry, but with more above it. No, there's only one in there. In any case, there should be more entries in there. I'm not sure why it didn't grab all 196, but that's fine for now because this data essentially in this one entry would be replicated 195 more times with the content being the same. So now we can take this data and the index that we created and we can ostensibly place that into our portal, massage the facets and the search fields as well as the templates. And now we can have this data as, you know, part of that portal. So insert your data here is essentially kind of what we're talking about here. So that is really the process of ingesting data. We can delete everything in the index by delete by query. So if we do that and then we do this again, we should have 0. And if we want to really clean up, we can request this to be deleted, which I'm going to. And then we'll inspect that response. Whoop. And it doesn't delete immediately. It will be acknowledged true for deletion at some point in time. I forget that it's a pretty quick turnaround for deletion. But that's essentially the life cycle of an index from creation to ingesting to searching. And eventually, if you want to, if you need to delete the index. I'm going to stop here and see if there are any questions about this process.
So before I get to Mona's question, I just wanted to drive home one point. What you just saw Steve do was use the Globus Search API to create a brand new index. And then he did a bunch of Python gobbledygook to scan some files that are on his own system and pull metadata out of them or generate metadata about them and publish that metadata into his search index in Globus. And then he did a search, and then he cleaned it all up by deleting the index in Globus. The cool thing about that is that that index that he created is not on his system. It's not on Steve's system. It's in Globus, in AWS. So it's hosted on Globus's system. So he could just as easily have left it there, gone to a completely different system on the other side of the planet, done a search, and it would have found the data that he had published in that index. It's all hosted in the cloud. So I wanted to make sure that everyone was aware that when you use Globus Search, you're not building indices that live on your systems. You're building indices that live in Globus's cloud systems, and you can then query them and do whatever you need to with them, curate them, whatever, in the cloud, and they persist without your systems even being online at the time. Mona, you have a question.
Yeah, I think I have several. So first of all, I think I missed the part where the indices or the index is created or how that is created.
You missed it because it's so short.
I was muted there.
It's just one API call.
Yeah, the API call is right here.
Okay.
This is the endpoint. This is all documented too. If you look at the API documentation for Globus, these endpoints are all exposed and open in documentation. So I use the Python requests library, which is just a library to make HTTP type requests. And I hit that endpoint. I gave the index a display name and a description, and I used the auth authentication headers that I created with the SDK above. And then this right here, if you can see my highlighting, that actually created the index right there.
Okay. And so the data now for the index, you populated into the Globus cloud. How big are you guys allowing, and how long can we keep that index there?
Lee, I don't know how large the endpoint or those endpoints can get, or the indices can get.
I don't, it is published in the documentation for the Search API. And so maybe if we move on, I can come back with an answer to that real quickly. What I do know is that everybody is limited unless you associate your indices with a subscription, a Globus subscription that's paid.
Yeah,
you're limited to 5, I believe, 5 indices. I could be wrong. They change it every so often, but it's something small like that. So basically everybody gets 5 free indices. And then if you are on a paid subscription, you can have pretty much unlimited, I think. And then the size of each index, I would guess it's something pretty big, but I'm going to have to look it up for you. So if you have other questions, go ahead and those, and I will look.
Okay. And so basically, just so that I understand, the data resides wherever it resides.
yes.
What we basically are doing is grabbing the information we want to be part of the search and the answers,
Yes.
and submitting that to the Globus search indices.
Correct.
Okay.
Yeah, you're getting data about the data, so it's not the actual data. You're extracting whatever you need from it. And again, they don't have to be image files. They can be CSV files. They can be JSON files. They can be really anything that you can extract metadata out of and form into a gmeta list that you can then ingest into the search index. So yes, it is. I always like to say it's sort of data about the data.
Okay. Thanks. I think that answers all my questions now. Thank
Well, I actually found the answer to your question.
I'm curious too.
Let's see, the data limit here. Hang on a second. Oh, can I share my screen, Steve?
Oh yeah, sorry. Let me stop sharing. Go ahead.
See if I can find sharing more. Share screen. I want to share desktop too. Okay, so I'm just looking in the Search API documentation. There's a page called Globus Search Limits. And I'm looking here for, let's see, rules, fields. Looking for the big numbers.
I don't see any sharing screen, Lee, if you're sharing.
Oh, really? Oh, because
Yeah,
I
I
didn't
actually
hit
don't
the-
either, Lee.
I didn't hit the share button. There's an extra button you have to press.
There we go. Okay,
There we
okay.
go. Okay. So I'm looking at this Globus search limits page. And I think in the second table down, the maximum size of an entry is 10 megabytes. So every one thing that you publish into your index can be at most 10 megabytes. Your field lengths are capped at 32K. Your subjects can be no more than 500 bytes. Those are like the pointers to the files or pointers to, whatever IDs. Most people, just for your information, who are using search, put a DOI in there for the subject so that they can, use a resolver to move the files around without having to redo the index. And then let's see, how many entries? You can have 10 entries per subject. So for any file, you can have up to 10 entries with metadata about that file. And I'm looking for I don't see that they cap the size of the index.
Lee, they definitely do, because I ran into it at some point.
Really?
But I don't, I want to say it wasn't as big as I thought it was. And I'm wondering that if you do have a subscription, you can request that to be a little bit larger, because I can't imagine, some of the things that we're indexing at Globus, there's a lot of entries.
So one thing, fields per index. So metadata fields, you're limited to 1,000 total. Now, you can have up to 10 entries per subject, and each of those entries can have different fields in them.
Yeah.
But the total of all the fields that you have in your index can only be 1,000. And it's 3. You can only have 3 trial indices without having a subscription. And where is it? It must be on here somewhere. I'm sorry, but I don't see a maximum index size or maximum number of entries per index.
I think that means there's none.
Yeah.
All this is based on Amazon Elasticsearch, which is pretty darn cheap. So I wouldn't be surprised if the answer is that there isn't a cap, or if there is a cap, it's something that you can get lifted if you need to. So yeah, I mean, I can't imagine any other reason there wouldn't be. Yeah, I don't know. I don't see it on this page, and it should be there if there is a limit. So I think the answer might be, yeah. I know that we have some really big ones.
Oh, here.
Steve?
Yeah, this doesn't seem correct though. I did run in to something, and I had messaged one of our developers, Nick, about the index size limit MB for search index. And I seem to be hitting at about 2.5 meg, which seems very small.
Is that using a subscription, or is there?
No, that's not under a subscription.
Okay.
I'm just seeing if I can find anything else regarding this. Yeah. I think we might have to look into that. I don't know exactly what that limit might be, if there is any.
Okay, thanks. Yeah, I'm mostly
Steve,
curious.
I did find that if you query your index with the index with permissions call, it will tell you what your maximum size is.
Yeah.
And the example that they give is max size in megabytes is 5,000. So that would be 5,000 megabytes, which is 5 gigabytes. So that might be the default.
Okay, that sounds more reasonable. Yes, much more reasonable.
That's just a guess. That was just an example on the documentation page. So, bottom line, what you probably want to do is go ahead and create an index. You can create up to 3 trial indexes for free. And then query it and see what the size, maximum size is. And I also know that I'm certain that if you have a good use, they will increase the limit for you. So, all right, Jeanette has a question.
I might have an assortment of questions, actually. Hi, I think I missed a couple steps early on, and I was just wondering if you could give me a hand with that. So in the first section, when we were setting up the portal exercise, is it the case that once you start your portal, you can't actually effectively search even with the defaults until you've logged in? Is that true or no?
No, you should be able to search.
Oh, interesting. Okay.
Did you not get that with your portal when you set it up?
Yeah, so my portal was there, right? And I could see the search, I could see the various elements. I could click through to my the various data sets that were deployed, but I found that the filters weren't working, and I couldn't search for things. So I'm not sure what went on there.
I think I know what happened.
Oh yeah?
Yes, give me 1 second. Do you have your screen up in front of you?
I do. I have an assortment of things here, but am I still running? And then I tried to log in and I ran into other problems, so I'm not sure.
I think I know what's going on.
Okay, great.
If let me share real quick here again. I think it could be this simple. I'm hoping it is.
Okay.
Let me share. Okay, so we're looking at this is basically what we brought up. This is what we brought up. This is just deployed somewhere.
Yes.
So if you look at this, and I think what you're saying is if I click on Greenland, you're not seeing anything change?
Correct. That's
okay.
Correct.
I think it's this simple. Scroll down. Filter results.
Oh, no kidding. Okay. So there's just, all right. I was thinking, oh, I have to log in order to get this to go. And then I realized that I hadn't set up my login properly. So it's been sort of fun playing, right?
Yeah. So there's 2 things. The default, it's funny because there are some portals, I have to look at the default behavior of the portal because if I just click Greenland, it will filter by default. I don't have to go down and click any filter results. The other thing is that button is probably not in the best place.
No.
that might be better off here. So that you can see that clear and apply filters. So that's the issue, just the filter results. And if you want to clear them, go ahead and clear them.
So if we go and we filter. Okay, yeah, that's much better. Okay, I thought, oh, I have to log in. So then, right, I went to log in. Mona, I don't know if you have loads more questions. You don't mind if I'm hogging airtime, do you?
No, go for it, Jeanette.
Okay, cool. As long as I'm here. So I think I didn't set up my, let me get the lingo correct. I didn't properly register my app with Globus auth, right? So I was unable to log in. So what I had to do, right? I go to, let's see, developers.globus.org, right?
Correct.
And I make up some name, basically generate the client ID and client secrets. Now there's presumably
one more thing you need to do.
Client ID I need to put somewhere or associate with myself. I missed that part.
Yep. So when you go to, let me share my screen.
Yep. Hold on. I will go for it.
Okay. I'm going to share my desk. This time I'm actually going to hit the share button. Okay. So when you go to, that was not the right place. When you go to developers.globus.org and you
Mhm.
register your app with Globus, and you're looking at an app that you are entering, you have to enter what are called redirects.
Right, right.
This
And I
basically
think-
tells Globus what to go back to when the login finishes.
Okay, right,
It's like, because you hit the login button, it goes to Globus
right.
out of your application, but Globus needs to know where to send the person back to when they're done logging in. So
Okay.
you get this by putting in https:// the name of your instance that you got from us when you SSH'd, when you registered on our spreadsheet. And then basically you need these 2 lines.
Okay,
And
so this is on a successful authentication, go to
Yep.
this place. Okay,
Right.
great.
Yeah,
Great.
exactly. Or actually, it could be unsuccessful too. Where does it send the error to? So,
Yeah. Okay, where does the
either way,
error go?
that's
Cool.
you need this in order for the login to actually work.
Okay.
Yeah.
Jeanette, just as a side,
And you can add, just so you know, if you've already done this, you can add this at any time. So if you've already got your registration and your client ID and secret, but you didn't put in the redirects, go ahead and put them in now, and it should fix your login.
So the client ID and secret then get entered elsewhere.
Yes.
Okay.
that's part of the cookie cutter process setup.
Yeah, that's
how did I miss this? All right. So the
it
cookie cutter stuff.
prompts you for a whole bunch of things, and 2 of the things are the client ID and the secret.
Okay, I think I'm all right. So what I need to do is rerun that. That's great because I had gotten the redirects because I saw them in the instructions, but I did the wrong I entered the wrong thing in the cookie cutter. All right, this is awesome. Thank you for the guidance.
Yeah,
Sure,
sure.
Jeanette, too, just real quick as a side note, the redirect URLs, those can be local host too. So if you're developing locally on your machine just to test
Great.
things out,
Sure.
you can put localhost complete Globus in there as well.
Super. Great.
Yeah.
Thank you.
Right. I think I have the next portion of this too, right, Lee?
I've lost track. Sorry. Yes, you do. Are you going to talk about downloading and transfer links and things like that?
I am.
Awesome.
Yeah.
Excellent. Go for it.
Okay. I'm going to share my screen again. This is going to be mostly demoing two of this next portion is going to be is fairly complicated. One is definitely fairly complicated. So let me share here again.
Steve, so would it be okay with you if I give a brief intro?
Yeah, sure. Go ahead.
Okay, so the next section that we're going to cover in the tutorial has to do with those transfer links. So after you found something in the portal, you get these links. There's one link which is get a link to the web app that lets you download. Another is an HTTPS link that lets you download directly in your browser. And then there's that third one, which is just get a link that is to the portal itself. So basically, what Steve is going to show you are different ways that you can let people transfer data out of your portal, besides the ones that are the kind of the defaults. So
Yep.
Go for it, Steve.
Okay. So exporting data via Globus, easy to custom. Where is the data? We're using Globus Connect, so your data sets are in a Globus collection. We're presenting 3 options here, like Lee said. One is a simple link to the collection in the Globus web app. Very easy, but not necessarily customizable. Using the Globus helper page, it's easy. I don't want to say this is easy. It's easier than the third option here, and it is a bit customizable. And then the most complicated is a custom interface using JavaScript and making API calls directly to the Globus transfer API. So easy. What's easy? Easy is a link to the Globus web app. So what do we need to do in order to do that? We're going to add 2 fields to the Django Globus portal framework. One is called the HTTPS URL, and one is the Globus app link. So those would be located in your fields. Let me see if I can bring up, give me 1 second. And let me bring up. And here it is. Okay, let me pull this over. Let me show you an example of that. Okay, so here's the Globus app link. This is a field within the fields.py file. And here we need to know the portal endpoint ID, which is in our settings. If you remember when I went through the cookie cutter process, there was a part where I put the portal endpoint ID in. And we're essentially going to build a Globus URL with URL unsplit. You can really use anything you want here, but we're just combining the protocol with the URL file manager, and then we just need to know the origin ID and the origin path of the folder and file, and that is comes in the result files URL. So that's where we're building the app link. The HTTPS URL is again an entry in the metadata in the files, and that's just a simple result files URL. So we need these two fields so that when we look in this detail nav, will be two components. Oops. Let's find the templates. Here we go. And I may be in the wrong. Let me see that one more time. It should be V2 components detail nav. I might not have that in here. It's weird that I don't. But anyway, when you look at the Globus portal framework and the templates within, the two necessary items that you need. Now I've lost. We'll go back to here. Are HTTPS URL and these Globus app link fields. So then if we go and look at, that's a bad example. We'll use this here. So this is the data that was indexed by those images, those exit data. And if I click on a subject here and I click on this, this is where the Globus link comes in. It's going to open up another page and give you all of the files that are in that particular collection and directory. So from there, we could click on any number of files that we want, and we would transfer or sync to. I'm going to transfer to, let's say, GCP here, projects, Globus, tutorials. I think this is writable. So we review that. It's completed. So if I go back to my file manager and I refresh, I should see those two files, which are right here. And I can delete those as well. So that's the easy method. And additionally, if I go back to here, you can download via HTTPS. So this is going to ask me to log in. And here's, it's actually going to show me the image. And from here, I would just say save image as. We could also get the link to share. So this is that link to the JPEG. Copy it and send it to whoever you want. So that's the quote unquote easy way.
So before you go on, Steve, I just wanted to sum this up a little bit and say what Steve just showed you was that by pulling the information about where the files are located from the index itself, the Globus Django portal can build these nice little transfer and sync links or download via HTTPS links. So basically, that's using the information that's in the index to build up links. Okay, so it's not like the portal itself knows anything about where the data is. It's really more that the index stores the locations of the, or at least enough information that the portal can then put together an address.
So from there, we can use what's called the Globus helper pages to actually select a destination, using that helper page. So this is more complicated, requires some amount of additional setup. You get a little benefit from being able to have it being a little more customizable, but at the same time, the Globus web app can still handle any additional authorization or authentication that you may need after your initial login. So maybe there are some additional scopes that are needed for a particular collection, or just some additional elevated privileges that you might need. The Globus web app will handle all of that, which is really nice. So the helper pages, the browse endpoint is what you would kind of want to look at here. So if we just look at that quickly, hopefully it'll come up. A couple of things that are needed within this. The URL here is file manager with an action callback. The only required portion of this is this action, and that is what, similar to that complete login process where the web app kicks you back to your application. That's essentially what this is doing too. Once you pick your endpoint, it's going to kick you back to your application with a response. And that response is going to have the endpoint ID, path, folder and file information, and any label that is associated with this. So what does this look like in action? I'm going to use the this image data again. So if I click on this FEMA data, let's drill it down to a particular survey. So now we have 5 data sets that are found within this particular survey. And you'll notice that you'll see a transfer data sets here. So if I click this is going to take me to an additional screen here. This is the search transfer view with a data summary of what you're actually going to be downloading. This is in here. We have 5 files at about 32 meg. This is the bulk of what the helper pages are doing here. So if I click on this choose different location, let me back up here for 1 second. Go back. This right here, the URL for this is essentially, now I've forgotten. The URL for this is that helper page URL that I just showed you with the action that's pointing to an endpoint within my portal. So I'll just click this. Let's click it. Go in. We have a label here. We want to say, let's search, and let's go back to my personal. We're going to pick the tutorials endpoints again. So when I click submit here, that's where that action URL is going to come to play. It's going to redirect back to that, which is essentially this URL again, but with this data query params appended to it. So now I know the endpoint ID that I'm sending to, the path that I'm going to send it to, the label, and then the results. Let me quickly do this. There we go. So now if I click transfer data here, transfer started, I can view it in the web app. It's saying I'm offline, which I'm not. Strange. Let's try that one more time. Can I browse it from here? I sure can. All right, let's try that one more time.
Well, I mean, Globus will eventually figure out that your GCP is online. It's just
Maybe it just did there. Nope.
yeah. That's very strange.
Never mind the local host change. It's just some issues with running this on a local host.
So what Steve is showing you with this helper page is that it's another way that you can do a transfer out of the portal. And the way it works is that you basically let the user browse other endpoints in Globus that you want to transfer the data out to, and then click that submit button, and it comes right back to your portal, and you can hit the transfer button, and then your portal can do the transfer, and it submits it on your behalf. So basically, rather than just linking out to the web app and showing you the data where it lives and letting you transfer it wherever you want it, you can instead say, okay, I picked my data already in the portal. All I have to do is pick the other place that I want it to go to.
Yes.
And then you basically get a simpler Globus app interface. It's not the full Globus app web interface. It's a simpler one that just lets you pick the destination. And when you click that submit, it goes right back to your portal, and then you can hit the transfer button. And the advantage of that is that rather than the user having to find their way back to your portal from the Globus web app, when they hit submit, it automatically goes back to your app.
And do you have a sense from maybe clients that you've talked to which way might be less confusing for the gateway users?
Yeah, go ahead. Sorry. Yeah.
The thing is, everybody has opinions about what is more or less confusing. We have not actually done any user experience studies that would provide data that we could actually rely on for that. So I think the answer is I don't think we have an answer for you, no.
Okay, thanks.
You'd have to use your judgment for what makes sense for your application.
The one caveat to the helper pages is not included in the cookie cutter yet. That is something we should probably have a conversation about and think about adding that into a cookie cutter as an example.
And I think I'm translating that in my mind, Steve, too.
Yeah.
I think what you mean is that if you deploy your portal with the cookie cutter, you won't get the helper page option. Is that what you're saying?
That's right. That's not built into it.
You have to rejigger some things to enable it. Okay.
Correct.
Yeah. Okay. Got it.
Yeah. So those things are within the portal framework are updating 3 files and adding 1 additional. So the updates are to the URLs, views, search results, and we need to add that search transfer template that I showed from before, all with some varying degrees of difficulty there.
So we could walk you through, how to do that if that's something that you want to do in your own portal.
Yeah.
But it doesn't come by default.
Yeah.
And again, the reason that it's there as a possibility is because it's a little bit more custom experience than going to just taking the person to the Globus web app, linking out to the Globus web app and letting them do the transfer themselves. This basically lets them come back to your application, and you get to present the big red transfer, start the transfer button if you want to. And your application can then, if it wants to, monitor that transfer and get the transfer status. You could poll the transfer service to let the person know when the transfer has finished. That's something you can do with that interface. So it's a little bit more customized than just transferring out. It's also a little bit more work.
Yeah.
And I think Steve now has option number 3, which is a lot more work and a lot more custom.
I'll go through this quick because I see we're coming up quickly on time, and we still have another segment to go through here. But advanced UI, a very custom UI that uses the Globus SDK. So how do we do that? Advanced customization via Django REST framework and JavaScript. Yeah. Don't cringe at JavaScript, please. I actually like JavaScript a lot, especially React. It's much more complicated because this is all custom. So we're using something called the DRF, the Django REST framework. It's a really cool, easy way of building out APIs from within your application. So I'm actually using the Django REST framework to make calls to the Globus API to get easy results back as JSON. And then we're calling that API from the JavaScript front end. So you have a front end and a back end kind of separated out. We're using React as JS for the front end. If you're unfamiliar with React, it is a JavaScript framework, much like Django is a Python framework. They do different things, but similar when you're speaking about a framework. We're using two big packages within React, one called Recoil. This manages your state, your front end state. When you're working in what's called a single page application, you are letting JavaScript sort of take over as you're templating, and you're clicking back and forth from different templates within React. And while doing that, you want to keep track of state as you move to each section. So Recoil helps with that. React Router actually helps with clicking to different parts of your application. And then we're using Webpack to sort of package all of this JavaScript and React up. Why? Complete control over form and function and benefits of a single page application. Downsides, it's very custom and you have to know JavaScript and Python fairly well. The other downside is we now can't rely on the web app to handle any additional authentication or authorization for us. We have to do that ourselves, which isn't as easy as it sounds. I'm going to show you a sort of bare bones React Django transfer backend. There's still a lot of work to do on it, so I'm going to carefully and very controlled way show you transfer. So if I click on here, yeah. You've only seen two links up here so far. You've seen about and you've seen search. You haven't seen this transfer yet. So if I click on this, at this point, JavaScript and React has taken over. This is, I believe, yes, this is a tutorial endpoint. And I'm going to search for my GCP endpoint because it should work. So again, this browse is all handled in custom JavaScript. This window, as I click through item back and anything else is all custom JavaScript projects. Globus tutorials. Let's just send over a few files here. Hopefully it will work. It's accepted. If I check on the status, it succeeded. So if I go back here and I go back into my tutorials, I should see that Hubble and file 3 that is transferred over. So I'll just quickly show you, because it's not very exciting necessarily, but this. So here's my static files, JS. This is the transfer, and here's my source of all these. So these are all the files on the front end for the JavaScript that are taking care of this whole process of choosing data to transfer to another collection. Index kicks it off by finding a container in your template to attach the JavaScript to, and then from there. Everything is taken up by JSX and JavaScript files, some of which can get rather lengthy, as you can see here. So you can see why this is the most complicated form, because this is just the file that handles anything to do with a portal endpoint. Yeah, so that's the more difficult. So if you have a developer or you're a developer and you know JavaScript well and you know Python well, this is an avenue that you can take and get a really, really custom portal.
The other way to think about this is that what this demonstrates is essentially recreating the Globus web app in a custom form for a particular application. So, when you think about the trade-offs involved in this, if you are able to just link to the Globus web app, or if you're able to do something a little bit trickier, which is use a helper page that Globus provides for you, it's a little bit of coding that you have to do and maintain. But and you get a lot of functionality that way. There's all kinds of, really nice user interface elements that we provide for you in the Globus web app or in the Globus helper page. When you decide that you need to go further and you really need to have something super custom, you basically have entered the world of recreating our web app.
Yes.
And not to toot our horn or anything, but we actually have a team of people who are whose job it is to maintain that web app. And so you're kind of getting yourself into the business of duplicating what the Globus team does, which is providing a web app for doing data transfer stuff. I mean, obviously, it's your app and you can customize it and you can make it as streamlined and simple as you want to. But the reality is that there are a fair number of corner cases that have to do with, the authentication or authorization necessary to access files in different types of Globus collections that your custom app will have to deal with because you're no longer using the Globus web app. You're building your own. And so you have to deal with all the corner cases that the Globus web app has to deal with regard to, you authenticated with the wrong identity. We have to guide you to authenticate with the right identity. Or it's been too long since you authenticated and this is a high assurance collection, so we have to ask you to re-authenticate. Or, it's a mapped collection on a old GCS version 4 endpoint, and there's a different way to authenticate, and you have to have code to do that. So bottom line, you can do this, and React is really cool. Between those of us who are on Zoom right now, it took Steve, who's right in front of you right now, a shockingly little amount of time to put together a first version of this. But then it took a shockingly long time to get to a version that actually worked in all circumstances and around all the corner cases.
Yeah.
And so that would be the trade-off that you have to think about when you think about, oh, wow, I could have this really custom interface in my portal. Well, yeah, you could, but then it's a lot of code.
Yeah. So this is just one example here of a sort of pitfall of this. I just searched for a collection that I need elevated privileges for. The web app, the portal will tell you that there's an error and what that error is, but right now it can't handle that error, right? So if I go to the file manager here, and I search for Globus, and I click on it here, it's going to give me, okay, you need to re-authenticate. So what do? I can see what the details of this is, and I can click continue here, and it's going to say select an identity. And then I'm in here and I'm authenticated. So that's the benefit of the web app. We're hoping to get to close to maybe some type of functionality with a little more customizable option like JavaScript and React. So that's just an example of one of the pitfalls.
Yep. And there is light at the end of this tunnel in that the Globus team is currently working, the product team, not the professional services team that Steve and I are part of, but the Globus product team, which develops the web app. They are working on a JavaScript SDK, basically an alternative to the current Globus Python SDK, which has JavaScript features in it. And from that, you would be able to build one of these custom React interfaces. It's not available today, and it's something that they're kind of working on. We're hoping that by this time next year, we will have a version 1 of it that will be available to people, and we'll be able to include it in our future tutorials. But for right now, you would pretty much have to develop it on your own from scratch. Mm-hmm. So if, let's see, let's see if there are any questions first. And if there aren't, I have a few more comments for the end of the tutorial. But if there are questions, I'd like to answer them now.
Lee, I do have one question. Has Globus been used in HIPAA environments?
Oh, absolutely.
Okay.
Yeah, that's what our high assurance product subscription is for. And there are two different levels. One of them is with a business associates agreement with your institution, and one of them is without that business associates agreement. So a business associate agreement is basically a legal contract between your organization and the University of Chicago as the operator of Globus, and it covers all of the liability issues that come up in HIPAA. Like, if there is a breach, who pays for it? And it basically puts the University of Chicago on the hook for paying for, part of the costs of settling breach settlements. And so we have a one level of subscription that includes that BAA, and one level of subscription that doesn't, and basically just has all the security features that you would need without putting us legally on the hook for that. I mean, we're still somewhat on the hook, but not as much as with a BAA. So the answer is yes, and we have a good 20 or so universities that we have business associate agreements or HIPAA subscriptions with, who are using Globus to manage HIPAA covered data, health data. Yep.
Okay, thanks.
Yep. Anything else? That is one of those cases, though, Mona, where the authentication is a little bit different when something is HIPAA protected under high assurance. And so that would make that JavaScript code more complicated. And that would be a reason why you would probably want to rely more on the Globus web app to do things for you, because it will then say, oh, wait a minute, this is high assurance and it requires that you authenticate every 12 hours and it's been more than 12 hours since you logged in. We're going to ask you to log in again, and it'll do it for you without you writing any code. Whereas if you did it all in JavaScript yourself, you'd have to write the code to recover from that error.
Actually,
Okay.
I have a security related question. JavaScript is generally plain text. I mean, it is plain text. Is there any security concern because there are client secrets that will need to be stored? No? Okay.
No, all of the that's what the that Django REST framework, the back end, all of that stuff is stored on the back end. It's not visible to the client.
Okay. Okay.
Yeah. Okay, we've got 5 minutes left, so that's not going to be enough time for me to do really sophisticated demonstrations of our compute side of things, but I did want to at least give you the overview so that you have a sense. So basically, I want to give you pointers. So let me share my screen. There we go. Desktop 2 share. Okay. And I'm going to go into slide mode. Hello. There we go. Okay. All right. So we promised for this tutorial, we would talk a little bit about compute. And so we're going to wrap up with a little bit on compute. Globus does have a number of compute capabilities. 3 of them that are part of the Globus product itself are here on the screen. One of them is our timer service, which is the simplest form of automation, but it's turned out to be incredibly handy for a number of people because really all they need are either scheduled or recurring transfers. So think of it almost as a Globus cron, in that you can basically say, I want to do this same transfer that I just did. I want you to do it every night at midnight. And I want to be able to see a log of all the transfers that were done. And I want to be able to see, how many files were transferred every night, and be able to, check that. The Globus timer service can do that for you. And it's not particularly flexible. It's not like you can, make it do really fancy things, but what it does really, really well. The Globus command line interface is a good way of scripting things if you want more flexibility. and so and if you like writing shell scripts and things like that, the command line interface is probably the way to go. Everything that you can do in the web interface, you can do with the command line interface. The interface might be a little bit more difficult to deal with because you have to have things like UUIDs instead of display names. But you can, list, collect, search, you can search for endpoints, you can get the UUID of them from the display name, you can put it in there and do a transfer to or from it. Everything can be done with the command line interface. This also includes things like search and groups. You can do group membership with the command line interface, add and remove people to groups that way, get the membership of a group via the command line interface and get a JSON dump of all the members and everything that Globus knows about them. It's pretty powerful stuff. The last thing that I wanted to mention under automation capabilities is our Flows service. Flows is the 5th Globus API, and we didn't really have much time to talk about it today, unfortunately. But basically what it is it's a service that allows you to create a definition of a series of steps that have to happen. Transfer a file, delete the file from the original location, change the permissions on the new location so that the original person doesn't have access to it anymore. That would be an example of a very simple flow. Three steps that have to happen in sequence. You give it a name, Globus keeps track of it then, and Globus gives you a UUID, and basically then you can call an API call to kick off that flow anytime you want. And some flows have input parameters like what is the source, what is the destination, what permissions need to be set. Basically you can give it, you can fill in the blanks in the flow definition every time you run it, but it's the same flow every time. And Globus manages that flow for you. So once you say, kick off flow and give it a UUID, it's fire and forget, just like Globus transfers are. You can totally turn off your computer or whatever, and Globus will make sure that flow completes. Flows can also have human in the loop interactions. So there can be steps in the flow that wait for a person to go to the Globus web app and fill in a form, or click a button to say, yes, I approve, go ahead and do this. So it can have human in the loop things as well. The last thing that is not on this screen is something called FuncX, and the reason it's not on the screen is because it's coming out of the Globus Labs team and hasn't quite made it to the product quite yet, but it's being used by a lot of research teams already. It's essentially function as a service. So in Python, you define a function, you register it with FuncX, and then you can submit that function to be run on remote, what we call FuncX endpoints. So think of it almost as a place where you can run jobs. And instead of running jobs, you call functions. And so you call a Python function that says, run this Python function on this FuncX endpoint and let me know when it's done. And it's essentially remote computing using Globus security, identities and groups and et cetera. So those are basically your options for adding compute to your portal. I'm sorry that we ran out of time, but I want to remind everybody that we will be in San Diego next week. So if you have questions about that, we'd be more than happy to show you FuncX or Flows or the timer service or help you out with anything regarding the Django Globus portal too. So make sure that if you're in San Diego next week, you stop by and say hi to us. At the very least, we'd like to shake your hand or bump fists or whatever. And we'll be happy to answer questions or fill in things that we weren't able to talk about today. And I'd be happy to set up a meeting with you too next week. I'll be there Tuesday through Thursday. I'm pretty sure that those are the days. Anything else before we bring it to a close? If not, I'd like to thank everybody for your time. You all hung in there for a very long time. This is a very technical tutorial, and I hope that at the very least we gave you pointers to things that you can look at or look up more of later. I would also want to remind everybody that the Globus documentation is all available at docs.globus.org. And so pretty much everything we talked about, you can verify, confirm, and get more details about at docs.globus.org.